Well, hello and welcome to our 578th dive.
Still easy way of getting her to see stuff.
You are watching live footage from the remotely operated vehicle SuBastian. We're about 500 meters down. We've actually returned, for anyone who caught our last dive, we've returned to the site of our first dive of this expedition, but you might notice that we have some new equipment. So on that first dive, we identified some areas of interest, and we've now returned to the site, equipped with some mapping equipment.
But the other part of the package test, the X and the Y, is these tracks right here. So just be running these. Okay.
So good morning, good afternoon, or good evening, wherever you might be joining us from.
Yeah, it's going to be super uneven terrain, which was the goal, to map this kind of stuff. So it's okay, it's going to be rocky and all over the I sure can. We're on the deep end now, but it should only go up to a max of around 4 meters.
And she's saying,
Yeah.
She said, yeah.
I'll still chuckling about Daryl walking into that. It's like nobody's out there. Don't catch up. Whoa. What is that? I don't know. Let's go.
Standalone or WMS system. Most settings under IMS are grayed out.
Wow.
He's right.
Yes.
Users with integrated systems.
Hey, dude.
Very cool.
What's up, dude?
It looks like a Dumbo light. Oh, I don't see the big flappy ears.
No, there's no fins. Is it a 7-arm?
Alright. I don't know if I can help you too much with the lights. That is big.
It's a cool one.
Yeah, my guess would be a 7-arm octopus. I'd have to double check.
Can we turn off some of the lights, or do we want to have them on? Okay.
It's just kind of an awkward
Is it better for you guys?
position because normally we can put them right in front of us, but with the laser we got to look to the side, so none of our lights really point that way.
No, I'm saying the lights in the control room.
Oh, I think we're okay. Unless you guys.
No, that's fine. If you guys are better on this, it's fine.
You okay, girl? You want lights off?
I can't move down anymore. If you just follow with the camera,
Sure.
and I'll try to maintain.
It looks like it's about to touch down here.
Yeah.
Like a balloon.
Weird eye placement.
Yeah, it does.
Yeah.
Obviously, you can't see the ground very well.
It's gonna have breakfast.
I was just trying to sneak on this. Smart guy.
Mm-hmm.
Been around over.
Okay, to follow him a little bit.
Yeah,
You're
I mean,
still
the
messing
boat's
around
still
over
way
here.
out there, so.
You guys are still setting up for you?
Yeah, just a few more minutes.
Yeah, we'll follow this guy a little bit.
Yeah.
going.
All right, so a lovely way to start our second dive of the expedition. Of course, this expedition is titled The Vertical Reefs of Galapagos, and we were discussing some of the equipment that's mounted on board the sub. So we actually have 2 mapping sensors, and that's going to be a multibeam and also a laser scanner. And that laser scanner is the thing you saw kind of mounted in front of us. But we do have the multibeam as well. Nice. And our new equipment and the operations for today mean we likely won't be stopping and zooming on many things, but they're still getting set up. And this octopus was here to greet us as we got here.
Okay, let's download TeamViewer to that PC, and then we can give her access if she has.
We just scanned it. Or some on the left side. Just turn this one to the right side. Yeah, that's not right.
Access to remote.
Very cool.
Gives a little bit of backscatter, but
So welcome for all the folks trickling in, catching us on a good moment.
Everything's confusing.
we could try this lower ram light too. You know, I don't know if that'll do anything.
Oh, yeah.
Just ram out a little bit, and that should maybe do something. Want me to do it? Ramming out.
Should already, hopefully, be synced. Oh no, won't be synced because we're not
Cat, what
going
about
to
you?
die.
You don't like?
I don't think so.
Just
Yeah.
like 4 minutes really quickly.
Not for
Yeah,
that.
put it in the
The rocket might have been okay, though. That's without it.
A temporary file.
The rocket kind of helps.
Oh, that's pretty grainy.
Or do you guys want to put it in permanent ground? Because it won't automatically transfer until the dive's over. And then it's going to go in the ROV. But where would you want her to temporarily do it? In participant data.
Yeah, somewhere.
You knew we were going to see some amazing stuff if we got the laser right here.
Yeah, that's a good one, huh?
Okay.
Alright. Roger. I am zooming out. Straightening you back up. That's good flying there, Carl.
Right. Well, if that goes in there, she should be able to grab it from her computer.
Cool.
Okay, also
Maybe you
Stu says
can-
for non-integrated
Well,
motion
flying better
sonar,
than
a
left.
TSS1
I don't know
message
why.
can be interfaced to the
Maybe try it one more
buoy
time.
for an external motion sensor for roll
I don't want to
stabilization.
get him over there. Sure.
But where do you see?
TSS1 is a common data format for
Yeah.
most motion sensors.
So, just confirm.
You need to turn that off.
We turn this off.
It's too much backscatter, huh?
Interface serially to
Closer.
conform
Maybe look up
Can you,
order
can you
with the
stop the camera down a little
installed.
Yeah, maybe go back up.
Yeah.
Get a ripple through the water goes over his body.
Yeah, it's very cool.
Just gonna try with that rocking real quick.
Because this is still.
Oh yeah, it's good.
That's good.
There we go.
I'll get a shot in the gill there. Yeah.
Butt shot. Or mouth shot, as the case may
See
be.
the old undercarriage.
That's very nice.
So essentially, we are getting GGA and TS. I can just
Yeah,
pass
that's
the TS.
that's the
by
angle
itself.
right there. Is that left angle, huh? For some reason.
Yeah.
That's just better.
So we can. That is coming through column.
I'd say this
So you can hear them getting set up behind us.
Big.
19200.
I think it's easily,
The minimum baud rate for 50 hertz update rate is 192.
Yeah. So this is higher. So. But I just don't know
For
where-
most of this dive, we're going to be cruising along,
Yeah, that is right.
running some transects, mowing the
I don't
lawn,
know where you see it
so we won't be able to stop.
coming in.
But this is great timing for this octopus to show up because they're still getting that set up.
Yeah, so you got a good time right now.
Sonar indicator shows streaming status
Right,
and
your
advanced
cat real
data
quick.
types as requested by the acquisition software. Do we need to sort of start logging or something? This is the start.
Wow. Wow.
It's an excellent screensaver.
Just cruising.
Checking it out.
Just a little spaceship down here.
Wonder what we're doing in his territory.
Boats on the waypoint. We'll kick them off again.
Yeah, it didn't pop out. Sorry.
Yeah.
All right. So,
Let me straighten you up.
On the back end.
Yeah, no,
speaking about the rest of the dive, we are
Would that be here?
hoping to map some areas that we visited on the first dive. So again, the cruise is the vertical reefs of Galapagos, and we are using hashtag cliff reefs. But the mapping equipment we have on board is here to assist us in this, right? Because the cliffs are kind of difficult to map in a more traditional sense. A lot of the mapping of the seafloor is done with sonar systems from ships up on the surface, and so basically just looking straight down, and that leads to cliffs lacking a lot of detail, at least as far as their face goes, because the cliff from straight down is going to look pretty much just like a line that's very shallow on one side and very steep immediately on the other side of that line. And so for this cruise, we are going to occasionally be putting this laser scanner and the multibeam unit combo onto ROV SuBastian and using that to actually cruise along the cliff face and map the cliff face.
Oh, okay.
And we are also looking for corals along those cliff faces. So should be exciting to see what sort of detail we can get on those scans.
There's definitely no shortage of targets.
Can I share that?
Yes, once it
That's fine. Yeah, like when I see it, I'll kind of toss it up. All right. Let me see if I can show you kind of what the scientists are working with as far as their data stream. And it's going to come and go, but let me try and get that for you. I'll have to set it up.
Oh, so they've just been.
Hey, can I try turning off your sit for a minute? See if I should get anything? Sure.
I don't want to interrupt if you're.
Oh no, things are good here.
Good. Sit is going off.
We're just wondering if that's
Do we have websites yet? Do we have websites? We have offsets. Of course,
That is not doing.
So as you can see, our depth here pretty shallow compared to the last few cruises that we've done. If you've been tuning in for the previous cruises, right, we've been exploring about 2.5 kilometers on the last two cruises I was on, and looking at hydrothermal vents, and then obviously the first cruise we had here in the Galapagos, also looking at hydrothermal vents. But now with us looking at these cold water corals, we are a good deal shallower.
That's good to know. That is carefully stowed under this mat. What do you expect the drawings to be?
What's their swap? So we have this swap. So then they can check.
Just trying to pull on over the footage from our mapping systems on board the sub. We've put up the maps before that we're using from the ship, and kind of use those to show you dive sites, but it'll be interesting to see if we can pull up what the actual data is looking like.
So I think it's because the launch recovery is a different spot. So now that the circle covers all of those, but zoom in,
Yeah, but you can't make it. You can't make it like that.
oh, you're right. Yeah.
I think it's because see how your launch recovery point is just like start
That is what it is.
and mine's in the middle.
There's an offset. Juliana does it all the time for the launch recovery point, or maybe it's the Falcor waypoint. I don't remember which one. Yeah, it's the waypoint's on my launch, but it's not on yours. See how it's further back? There's an offset.
Okay.
I think it might just be. Are we streaming? Oh,
Yeah, you don't have any idea how to. That's what I don't think.
It's I mean, I don't know how this is either, but it's in here.
All right, so we've got Norbit. Let's see if I can pull that up here in a moment. We've still got folks trickling in. Wow, some folks from around the world. Kind of fun always to see where people tune in. Up front right now, front row, of course, I'm over in the multimedia technician seat, and my name's Alex. Next to me in the co-pilot seat, we've got Zach. And then piloting us currently, we've got Jill. Scientists are kind of behind me, working on getting their systems going.
20, Alpha 2. Man, all that seems.
Maybe it's nav items.
That seems the same.
All right, I'm going to briefly put this up, but we might have to cut away from it as they're still futzing with settings. But there's some of that raw data coming in. If you can parse that, or attempt to parse that.
I think I'm still comfortable with that. Are you? We could go to that position 27.
take the roll stabilization.
Nothing else we can just scoot a little further away.
Let's see. Yeah, folks noticing that we have a lot of stuff in the water column. So that's one of the things we've noticed here, right? We do have just a ton of stuff, even on the way down. There's just a ton of stuff in the water. Mostly little, mostly particulate, but we've seen lots of ctenophores as well. Lots of midwater cucumbers, sea cucumbers. So it's been cool to see.
And that's where you said they want it?
Yeah, you're pretty much there. Yeah. That's it.
You're wanting to face the rock, so like.
Well, there's for the heading thing. I don't know. We'll have to guide us a little more on that. But that rock right there might be just anyone that's kind of recognizable, you know.
I mean, there's a big wall right here at my base. Okay. To my left. I think.
Okay, if I just try sight. Yes.
Oh look. See your little waterfall there. Hopefully we can get that on.
Yeah, you want it over there?
Yes, please.
Okay. I will do
Where
that.
the chat is would be good, or
Okay. Yeah, we can toss it up somewhere. It's too bad that all these ended up working because I could have just put it on one of those screens. I mean, I still could actually, but
Yeah, if you want to, that one.
I can split that so it still has a smaller view of that, and you'll have waterfall.
Yeah, it's probably alright.
Okay, let me know. I'll futz with it here. We're just getting all our monitors set up.
but yeah, ideally that'll be
The pilots would love to see the data off the mapping as well. So we're currently working to get that set up for them.
I want that bigger. I don't know.
Well, I think they can zoom in kind of like they did with that. Yeah, depth thing too. Alex can do anything. He's a manger.
Oh, I thought it was that screen.
Yeah, so in her kind of she's for
Yeah, she's this. And we can stream it to everyone.
Pretty tiny.
It is.
Yeah, I can put that somewhere else.
Is this screen going to be important for this?
Oh, for this dive, actually, probably not. Yeah, let me put it up there.
Do that one.
That's a good call.
About the time
Okay,
on
perfect.
there, just in case we go away again.
Yeah.
Quick reference at least.
Right.
Roll stability, it's on. How'd that happen?
It's on, yeah. Click the
Plus,
button.
I have
There's a button?
sonar to
Well, once you set it up, yeah.
Oh, it's right there.
So because
Something
it
like
was
that,
getting TSS1.
Air work for you, like
Yeah.
where it sweeps faster.
Yeah.
So
why is this not-
Alright, Jill, I got you there.
So
All right.
no, it doesn't
And then I'll fix this back here now.
So
What's the range I'm supposed to maintain?
because I think
Well, I think it's going to be about 10 minutes.
Yeah,
But let's
Yeah.
In?
Your HDs are all going to blink for a second.
Do we want 7?
Yeah, kind of 7.
It depends what we're doing. Like for the LiDAR, it's closer.
We're gonna go
For the LiDAR, it's more like.
That's 7 with
and then
I thought it was like 1.5 or 3.
Alright, sorry about that, folks, but yeah, it looks like I'll be able to set up a little scene here for you. So you can see that that waterfall coming down.
For that, you'll be flying throughout.
And yeah, we've got a multi-beam on board for some mapping, and then we also have a laser scanner, which is good to down to like a resolution of, it's like millimeter resolution. So some of the scientists on board were talking about being able to like not just model, but then you could even 3D print some of these little things, and we'll be able, hypothetically, be able to see like the polyps on the corals in those 3D captures. So very exciting tech that we've got on board.
Sweet. That's 10 meters.
That's all.
All right, let me set up a little picture-in-picture of that waterfall for y'all.
Wow, some really colorful stuff there. Those bright oranges.
So yeah, unfortunately, with us doing this mapping, that does mean that we're going to be kind of just scooting and shooting. We're not going to be really stopping for much. So it might be a little bit of highway bingo of just trying to spot stuff as it goes by.
Timestamp of this in. As long as it's timestamped
We shall see.
anywhere, so-
the rest
Yeah.
of it. Yeah,
We might see some midwater stuff because we're actually going to be up for some of these scans. We're going to be up off the bottom by a decent amount. What's the highest in meters we're running?
When we do the lines?
Yeah.
50.
50 meters up. So not too much in the way of bottom visibility at that time, but who knows? We might bump into some things up in the water. Although, again, we won't be able to stop for them, so just kind of seeing what we see when we see it.
Yeah, right, yeah. Well, we don't have
Again, folks still trickling in, so for anyone who might just be joining us, welcome to another dive. This is our 578th dive with the remotely operated vehicle SuBastian, and we are down just shy of 500 meters off the Galapagos, looking at some corals growing on some cliffs. This cruise is the vertical reefs of the Galapagos cruise, and so we are interested in those reefs that are encrusting some of these cliffs. I mean, we've seen some shots of what we could potentially be encountering on some of these dives, and it's wild how much coral there is, but you never quite know what you're going to see when you get down there.
So that would be a pitch. There's so many competing next to the roll.
It's on the screen right now.
Yeah, this data will be combined with the location and navigation data from the ROV to give us a better understanding of reference, what we're looking at, where it is.
Oh, check out, there's one of those with eggs again.
Oh, yeah.
Okay.
Yeah, so we've got this little chimera kind of over on the left side there.
Did you give him a zoom? Sure.
looks to have some hangers on.
So before we actually,
It's like scary. It's like, oh man, this on me.
Yeah, just bumping into the light there.
I'm not too happy with the errors I'm getting with the DVL.
Or bumping into the
I almost want to stop.
ground.
Yes, it's going through the same Ethernet can, and I'm almost wondering about the traffic, on whether you can actually configure something while that is running at a high rate. It doesn't seem like you can configure the DVL, like the series.
Okay.
And so right now they're not getting altitude when they should be getting altitude. And if I can try to set them up before we start recording and hoping that everything will be fine. Yeah. Just because I think there's too much traffic going on the Ethernet line is what I'm assuming is
So
happening.
when we turn on the laser,
Same thing. Same thing will happen. Yeah.
Now that we
Yep.
things, save configuration.
the laser can log all the data.
Mhm. Yeah. But yeah, it's just weird that
So I will stop recording. I'll
disconnect.
Is that enough?
Yes, that should be good.
Yeah.
And then hopefully traffic. I don't know. Comes in and make sure this. Or
Maybe it's the depth, but I don't think I've ever seen so many cool fish in such a small area, you know?
Yeah, there's going to be some neat fish this cruise for sure.
Everywhere you look, there's a new one.
Have altitude a little bit high up to auto detect. The question is whether we move it on down altitude. And the fish. Yeah. Can we zoom in on the back fin of the fish while we're looking at
Sure. The back fin.
the back fin of the fish?
Still getting the gear set up, so they're going to get some zooms on fish, it sounds like.
So, quick question from a dumb guy though. I only see one fin on the top. Is that
I think
so?
let's zoom in on the. Let's just zoom in on the fish. I was just
Let me fly in. If we zoom in, I'm gonna do some more story.
we don't have to.
He's always
It's
really
okay.
That's good.
confused, so we don't want to make it any worse. You know? His natural state.
There we go.
He's even showing off. Look at that.
No, I don't think it's
So is that what? Is that what they want to see?
I'm not sure. But that must be the diagnostic feature.
For some reason.
Not a request.
So you can tell the different models apart.
Yeah.
But it's kind of almost like an iridescent. Shimmer on it.
Yeah,
So there was a
nice zoom.
okay, perfect.
So y'all are troubleshooting the Norbit right now?
The
Your DVL.
DVL right now. Too much.
Yeah, but I'm not even getting.
it.
It's weird. I'm not even getting pings from it. Oh, because I have it off. Silly.
I get
Oh,
very
look at that
nice.
fish. Look at that fish. Zoom in on that fish. Yeah.
Tiny.
I don't know.
Sure. Zoom in one time.
Is it a- on that?
Oh man, that guy got run over. You're not waiting on any offsets from Jason Williams, are you?
I think we got them.
Yeah.
We got them. Ooh, zoom in on this guy.
Oh yeah, we've had these little cat sharks a couple times.
Can we sing it? Baby shark?
Don't do it.
No.
All our biologists are in the other room. Yeah.
Whoop, nice. Cruising on by.
I do benthic invertebrates, so my extent is fish.
Yeah, before we get started on the mapping, we can have a few zooms as a little treat.
Cute. Hey man.
Oh, nice buccal action on the gills there. I guess that wouldn't be buccal on that.
What's going, friendo? Think I can do one more zoom bump for you, Carl, or that would be too much?
You can try it.
Yeah, buccal.
Oh, wow, the fish are really liking you guys.
So you can just chill there.
Fish are friends.
What do you think? Just whisper into that one.
He's saying, are you seeing this, man?
I told you aliens are real.
That's it. That's it. They're having a discussion about the glowing vehicle flying above them.
I think if we don't move, it can't see us. That's what they're saying. Pretty hard to come back out. Okay. Go.
Yeah, fun shot with those gills pumping.
Oh, nice.
Yeah.
Flying with a crooked camera. It's my favorite.
Yeah, I mean, I guess I can kind of show off what you got going here as far as your layout. So the pilots, because we have the laser mounted on the front there, and the mapping gear, the camera's just slightly skewed.
There's, 3 cases in.
Because if we just line it up straight on, then we're looking at the sensors, the mapping equipment.
There's
So
symptomatic that they
That's one now. That's travel stuff.
scientists always are there.
Did he? I guess we should figure out what this protocol is.
Outbreak protocol, but he said that before.
yeah, something peeking out of the sponge there. Some sort of little crustacean here.
if you want something.
Pretty good on, and then you can zoom.
Zoom in on that coral.
Yeah, which one specifically?
Let me see.
Pointing at it. Okay?
Yeah.
We'll then do it. Sure.
Curious to see. Does it have that?
We'll wait till you say go, Carl.
Yeah, go ahead.
Oh, we got a guy sitting on there, too, isn't it?
Yeah.
You know what was that?
A little more. Normally we can sit down, but I think we're a bit nervous with this big
The laser cap not perfect. Just make sure you don't go too close.
How's that for you?
Yeah, perfect. We can zoom out. I would say we're attracting fish.
Think we're
More
attracting-
and more fish.
They are pretty cool. I would have them.
There's some species that get scared and some species that get attracted.
You run towards the danger. I like that guy, he's cool. That's a cool
Yeah.
shot, really. Morals.
Yeah, like the little shrimp.
I guess if you get tired of flying too, Carl, we might be able to stick one rocket out the country.
Oh, okay.
Yeah.
We're tickety boo here. Can you zoom out a little for me? Sure.
Yeah.
Oh, we'll have to get Russ in here to do some piloting.
Oh, he's coming
See
soon.
some.
I think they were on at 10 actually.
Oh, he might be up. Might be on soon.
See that underneath the rock there, is that? Right in the center?
Like a shrimp?
Is that what it is?
Are you talking about?
I think there's one at the edge there. Yeah, a little shrimp.
Oh, yeah, it is a shrimp. I thought it was something cooler.
I mean, shrimp is cool. On the thing.
Yeah,
Yo!
definitely a shrimp. Yeah. It's like, oh man, leave me alone.
Oh, come on, man.
I am out of here.
Stop bullying me!
Yeah. Away they go. Go find another overhang.
Oh, look at that guy.
That's what, yeah, we're gonna check him out.
Oh.
Got a gastropod.
Wow, that's very.
Ooh, weird.
Video would be quite a little higher.
Zoom in a
I
little.
saw a unicorn you were doing to see the yeah.
What the heck is that?
Is that part of the
The inside,
it's the insides, yeah, it's the barb.
It's still defeated.
A barnacle kind of thing?
No.
What is that?
Sometimes you see them with the tentacles hanging out.
Yeah.
Yeah.
It's weird, right? It looks like the outside looks like a sponge almost.
Oh yeah, it seems to be covered in a little. Yeah,
It might be it might actually be a sponge.
Yes. Uh-huh.
Huh.
That's so weird. I don't
I'm trying to stay steady. I don't know why it's so bouncy.
Yeah, a little bit more. I think
Maybe that's what it is.
What's up?
Yeah.
Alright, here you go. Yeah, I think about 75, see if that makes a difference.
Oh, yeah, some good better already.
See what makes sense.
Still pitching good.
mean, they're 130 foot, so probably a little higher. They'll just fly out.
They put right here question mark. The biologists are probably all
Stop here. I'll stop. Zoom out again.
Just a nice little area for us to touch down in and be looking at stuff. Oh, basket stars, it's all extended now. The other ones we were seeing were pretty closed up. Yep. They're cool. I've seen them like wrap around little krill and stuff. Like little shrimp and whatnot. Yeah. I mean, that's just what they were being fed at the time. It was in human care, not here. But seeing them kind of coil up like that was pretty cool.
Usually when I see them, they're all tightly clipped up in a ball on a coral.
Yeah. We saw some our last dive here, but they were all pretty closed up.
No, not putting it into there. It's just too much data trying to come back up.
There's a black coral up there too.
Playing with it, that is right.
You can hear the scientists working in mission control here, getting their equipment hopefully set up. This will be our first time deploying with this gear. Of course, we test it while the sub's still on deck, but then once you're down and scooting around, things are a little different. So just trying to see if they can get it going.
Have we tried?
And I'm just cycling power.
I'm sure you have. Have we tried putting it back all the way?
That's what I've done. Yeah, normal.
Still nothing. Because that shouldn't even let you.
Well, that Ethernet bottle, that's how I'm changing the configuration of
Right,
it.
but that's all that should be. Just changing the configuration. The actual data should come up to normal.
Yeah. So I was thinking, because I couldn't even talk to it. And then that's why I was concerned. It was the data line, because I couldn't even talk to it through the, because I was talking to it.
Lots of these sharks.
So I wanted to shut everything down so I could have a clear line of communication with it. Try to change it back to DBL mode, right? And I initially, before going down, you asked about it, and I put it into DBL mode to make sure, but it's still not coming up. I did full DBL mode. And I'm just trying to cycle power and stuff to see if it comes back, but nothing seems to. Because if you cycle power on your end, the sprint system like that will just ruin your heading. You won't have heading for.
I'm not seeing any. Even our ground fault now that we have has gone away.
Yeah.
So I'm not really seeing any indications of anything.
So I'm gonna turn it. I'm gonna turn the power pass-through back on.
Yeah, but if you need us to do anything, man, just let me know.
I just don't know if you know pretty much anything further. Just keeps on again rejecting the DVL, and I don't know why that would be.
So the IMS is rejecting the DVL?
Yes.
Yeah, I would think, to be honest, that the next step would probably be a power cycle.
Yeah.
And then
that's what I did.
Power cycle, and then maybe try and change it, and then change it back from bottom lock to whatever.
Yeah.
But I mean, if we do that, we'll lose our heading for a while. But I mean, if it gains what we need for this dive, then I guess it's probably worth it, right? Even if it takes 20 minutes, it'll still be faster than recovering.
Yeah. So I'm going to try to restart the program. It should take a while.
No, we're still.
But
So we'll lose our position probably, will we?
you could go to USBO, but you won't have headlinks. Right? That's the biggest thing. If you guys cycle power to the INS, but just hold off on doing that for now.
Yeah, we'll not cycle power for to the INS until we hear from you.
Yeah.
So for now, I'm going to go to USBO position now.
You're good to stay in INS. Yeah.
I got it. Yeah, obviously that was made by a dude. So we need a lot of people holding the wires. Here, whose child is this? Here.
Sorry, Josh. So, question.
So essentially, the ROV sprints off. Obviously, it's not getting the DVO. So it's not getting altitude. My concern is it's going to hamper any collection systems we get. If you don't know, you don't necessarily want to map with DVO map does not work, right?
We said hi.
So we're just
So we're pretty much just
So yeah, if you want the lights off, I'm sure we can turn them off. So the basic status right now is we've come over here. This L right here is the patch test.
But yeah, that's pretty much where we're at. I don't know why.
just waiting because I can also play with
So
lasers.
they're having some issues with the
Well, I was concerned that the rate was
Mm-hmm.
gonna mess with
and then that'll take another 20
me
minutes.
being able to communicate with
Well, for now,
DVO.
it is what it is. The bolt's right here. This is the position that it really is. I think is on the curl screen. I think my offset is not right. So I think a few of those points are in circle of depth. But the idea is that we want it as close as possible where we can still do them all. So that way we do the CGVs and we don't have to move it all around. So that's where we got it for now. But if y'all want to move it somewhere else, you can. Just check the jumbo and then we can do it. Other than that, as soon as our data is good with DVL, we're going to be doing a patch test here, and we'll start to do the lines. And this is the diagram here if you want to move it. But it's just basically working out their direction here. What lines you're going to run, and what height you're going to run, how fast you're going to run. All that needs to be auto avoidance and auto altitude. How is it? Or auto depth because the bottom is super rocky. So we're doing this all the time.
All right. They're still getting our equipment figured out.
It's light. It's maybe just a touch too light, but I got it trimmed down right now. So it's just, it's.
You want to do that or I'll do that? Yeah. This guy's back too.
I have it trimmed where it just slowly floats up. What I've been doing is I've had a little left and zoom in, so you can kind of see like smaller wind on it.
So this guy keeps coming and going. So he doesn't really seem really
Doing the good old turn it off, turn it back on.
We basically turn on and off everything except for the INS and the science camera. And it's still there, and then it also goes away sometimes. And do it the whole time. Stop it. Oh, we tried it off, but we turned everything off. It's still there. We tried it off that. We tried everything except for the INS and the science. Okay, well, so shut up. Yeah, but it does go away too. It just comes and goes as a previous time.
We've also got a bit of a watch change happening here.
Also, obviously, when you're flying around, just that laser.
We've got
so be really careful not to-
Ben and Russ jumping on the ROV controls.
Check out my friend Zach. Let's see. You do lights on? Or is that like that?
We've got some
That's
hellos.
what it does.
Yeah.
How's it bad for these?
Yeah.
Hey, Alex, can you do me a favor?
Yeah, what you got?
Can you say hello, John and Donna? On top of you.
All right. from Falcor 2, we've got hello to John and Donna. And for anyone that might just be joining us, we are currently chilling at 481 meters below the surface. This footage is coming to you live from the remotely operated vehicle SuBastian by way of the research vessel Falcor 2 back up on the surface. This is the 578th dive and the second dive of the vertical Reefs expedition here in the Galapagos. For the second dive, we've actually returned to the site of our first dive. So if you tuned in for any of that, it might look a little familiar in some ways, but this time we return with more equipment. So I can show you kind of our porch there. You can see it is devoid of our bio boxes. We don't really have a lot in the way of collection gear, at least not physical collection. So we are here for data collection. We have a multibeam and a laser scanner attached to the front of ROV SuBastian here. Yeah, all this footage is getting to you in quite the manner, right? Of course, to pilot the ROV, our pilots need to send signals down a 6-kilometer long umbilical tether that's connected to ROV SuBastian, and then they can receive data, including the video that we're seeing, back up that umbilical. But in order to get that out to you, it gets piped around the ship. It gets piped into our broadcast computers, which I'm working from. And then that gets pushed up to the internet via a couple satellite connections that we have on board.
So, nothing has worked trying to get the DVL back. I was wondering if we could actually cycle power to the INS, and then also to the but you will lose heading. But if you change your positioning system to USBL,
They'll go to screen, just go to that one, go to field position, do the outside to fine, and see cycle INS now.
I'm going to pull up something here for y'all, just to show you kind of what we're working with. As far as a plan goes today, but again, we are running into some issues. So I'm just going to put the map up here.
it'll be a little while for it to set up, maybe.
You can see we have quite the little route planned out. So all those little yellow dots are places that we're wanting to hit. We're also looking at doing some runs at like different elevations. Yep. Messing around in the system there.
Now you've got your backup compass. Reset the counter.
Yeah, we're real close to the equator. We're actually at negative 0.52 lat and about negative 89 or so long. Closer to negative 90. Yeah, like negative 0.52 and negative 90 or so. That's roughly where we are. So if you look that up, you can see we are still quite close to the islands, the Galapagos. And this cruise is going to stay pretty close. Got our white balance redone there. As far as our weather today, let's take a look on up top. Got cloudy skies, but not too cloudy. Nicely cloudy. It was more significantly overcast the other day. But we are not looking too bad. We always keep an eye on that, though. As you know, sometimes that can play with our connection to y'all a little bit. Make our internet just a bit worse.
No, yeah, no, it's still coming up.
Take a look at what we're pushing right now as far as internet. We're doing about 3,500 up right now. I know folks sometimes are curious what our connection is, so we're doing about 3,500 up, 30 frames a second. And we do stream in 1080 when we can. Sometimes we drop that down to 720. And folks joke about us being able to do 4K up. Of course, the footage is recorded here in 4K, and you'll usually get some highlight clips in nice 4K. But pushing that up, that would be quite the push. Yeah, it's a good point brought up. You've got some various sites out there that sort of track the movements of ships. And usually when we're way offshore, that's like locked behind some premium. But we're within distance of shore tracking right now, so you can actually sort of find where we are. Of course, being closer to shore, we're having these shallower dives for this expedition. Lots drifting, but is the current very bad, Ben?
Oh, that's not too bad.
It's not too bad. Just looks worse. Things drift. Might be joining us on Facebook or on YouTube. We stream on both those currently. And if you have any questions, you can always type them in the chat there. Can't guarantee they'll be answered, but when we see questions that we can answer, or we have a moment to answer those, we do like to answer questions of folks watching the stream. There you can see that rig that's attached to the front. And so this is something we can swap in and out. For this particular dive, we're looking to do some mapping using ROV SuBastian. So it's currently installed. But then for collection dives, we can take that off. There may be some dives where we're cruising along expecting to collect. We find something cool that we're like, oh, we should map this. And then we'll swap in this gear up at the surface, send the ROV back down, and get a good scan.
Got altitude. Lovely.
All right.
Good, switch
Yeah.
back.
Happy.
Okay, IS position. Yeah, as I look in.
Yeah, the bandwidth requirements for 4K streaming up are pretty rough. Honestly, we keep our stream at the very low end of what you're supposed to be doing for 1080, and it seems like y'all are quite happy with what we've got, so I'm glad we can provide that. Nice clear views. Sometimes YouTube compression really doesn't like scattered things in the water, so fortunately we don't deal with a ton of bubbles since we're down pretty deep and that pressure keeps them away. But for things drifting around in the water, sometimes that encoding can get a little rough. So we've got altitude.
Yeah, so essentially what I was thinking is we'll keep the DVL in normal DVL and not ADCT until we want to do
We'll do the dedicated.
Yeah, because something there was hanging it up, and the only way to get
You can hear the scientists coming back in.
Alright.
So, and I don't want to say it's because it's all the network.
Our marine technician, Josh, was working quite hard to get some stuff hooked up here for him.
Alright, so we've shut everything, so the
Yeah. So the multibeam stuff, yeah.
Are you getting INS data? Yes, we are. We are INS calibration. Position control. We don't care here. So this is that for data quite right. Like they just say. INS. It doesn't work without it. Doesn't work very well.
The INS SSB show you the part.
Reasonably. Reasonably.
Oh, the manual? Yeah, I have it under manual. And voice. You said you had another more in-depth manual?
Got multiple.
Different versions.
Different software. Okay, so I put our data.
SSB? Yeah. Okay.
All right, so as they're getting a little more set up back there, sounds like we're making some progress, but welcome. If you're just joining us, we are about 473 meters below the surface off the Galapagos. You can see, for anyone who's joined us for some of the dives earlier this year, down maybe like 2.5 kilometers, that here at 475 meters, the water is quite a bit warmer.
So that's good, right?
We're looking at almost 8 degrees C versus like 1.8, 2.
So this should be current.
One of the other things that might happen this cruise, we're looking at potentially having the CTD doing operations at the same time as the ROV. So we deploy those off opposite sides of the ship. ROV SuBastian gets deployed off the starboard, and we have a J-frame that swings out on the port side with the CTD.
Are we able to do that?
Do you want navigation?
If we can,
Yes,
just for the
so-
tags,
Just for what?
for the geotag.
Yeah. So if it's column 1, it'll be 115.2.
No, it's something that cat record.
Let me just double check.
The Norbit is from UK. Something. Line scan.
Should be GPA strength only. Whoa, the protocol. Sorry. Protocol. He's on that. Let's do that. I'm sending that. That's gonna give you pitch roll. That's. I love that. That's really good. Oh, it makes me so happy. As a surveyor, that makes me so happy.
Yeah, exactly.
Alright, successful. Set up data storage.
I've never seen it from one of the guys. He's the guy there.
Are we able to put it on the network successful day, or should I be using it?
I would say local, so it stays all within the dive, and so it'll only be available after that, as long as we send it to the right one. Okay, so it must be just going to the same folder.
Okay. Good. Good. Control. We're connected. Oh. So laser comes file right.
Another nice basket star. Always cool to see them.
Very good.
I was actually just checking the focus, which is good. What we found too is that there are a lot of particulates in the water, especially in the shallow part about 2,000 meters. Once you get deeper, it's better. Shallow is a lot of stuff.
All right, are we ready for me to press the start button?
We're ready to go.
All right. Sounds like they are finalizing the setup, hopefully.
Nice, yes, great. All right, I'm pressing start.
It's not about anything.
Mm-hmm. Right where we are.
We got it better.
I'm gonna pull up a map for you all here. So we looked at the ROV map a little while ago, and you could see all the markers of where we were hoping to go, where we were planning to look at. But there you can kind of see that little cliff that we're up against there. And ROV SuBastian's kind of right at the mouth of this little inlet on it. So, pretty cool. We're going to kind of work our way through this area. Yeah, so again, you can kind of see there's variation here. There's some areas that are quite steep, and then others are kind of these rolling terraces. And as you might imagine, looking down from above on this terrain, all we really know is that it's very steep. We don't get a lot of the actual detail of the faces. We just know that it's steep. And so the mapping equipment that we're able to put on SuBastian for this cruise, we are hoping to get a better understanding, a better look at the actual terrain and relief of these cliff faces. So for anyone just joining us, we are going to be kind of mapping along this area, which ultimately means that we're not going to be doing a lot of stopping and zooming for things, but we will probably still see cool things. For anyone just joining us, make sure at some point you jump on back to the beginning of the stream, where we had just a fantastic little cephalopod show there. But yeah, giving you a different map here. You can see ROV Falkor 2 off to the left there. And then we've got SuBastian, ROV SuBastian, kind of up towards the top, little yellow rectangle. And all these yellow dots is where we are planning to check out, are planning to cruise over. Again, we're not like stopping and zooming and collecting, but we are making our way. And for some of these passes, we're going to be 50 meters off the bottom. So not so much seeing things on the bottom, but you never know what we'll run into in the midwater.
Because we said it was local, so it could be recording on the laser, right? If I started,
yeah, that might be. See if there's files.
Yeah, we have nice maps of the area. It is quite shallow, so you do get a good resolution on the maps. The problem is, it's just once it's really steep, you're not getting a ton there.
Starting, yep, firing.
So this is expected. This odd flashing.
You might need to refresh that.
Just as a warning, I guess. The equipment does flash.
How much lighting do you want off on the vehicle?
Actually, the better is more light off.
Okay.
So whatever you feel.
All right, so that flashing is going to get more intense. We're dropping the lights on the ROV down. You can see the laser, which I wasn't sure. That's pretty great. We can see it.
We also want to put it on the gas.
I think lights is a bit more.
Some areas of local
Some light on the yellow navigation.
On the right,
Yeah.
4 terabyte.
We do have, we do go.
Might be good to
Don't
try
need to
to
get out
Set up the NAS.
yeah.
So we'll leave mids on, that's just.
Our ship is haunted by Spirit Halloween.
The rest will really not leave. Lights on.
Or is it locally to the PC? Is it getting put into the folder? I'm just wondering where it's going.
The default location.
So that's
Yeah. Please, if you are sensitive to strobing lights, obviously don't watch this portion of the stream. And this is going to be the majority of this stream.
But will we? Yeah, when she had this select.
All right. I'm going to show you some different views, but again, lots of flashing lights. So please, if that's a problem, here's the heads up. I'm going to cut to a top-down view that will show you kind of the strobes on either side. You can sort of see the angle we're getting there. So you can see at the bottom of the bar from where all this equipment is mounted, where we have the mount down at the bottom, there's like another crossbar, and on either end of that crossbar, we've got some lights there. All right.
Usually the file would go up to one person. Usually how it goes.
So I mentioned that we were hoping to get the CTD in the water as well. So I'm going to try and show you the deployment of that, because it sounds like they're gearing up to actually go do that.
Yeah, the XY data was
C profile 0.
exactly.
Okay. So there's
Great, science control, comms check.
Yeah.
So there you can see the port side door of the hangar with our CTD there and the Niskin rosette in the lower left. And I've got a different view that I'll pull up when it's actually deploying, and we'll be able to see sort of top down the CTD going in the water. So this will be lowered down through the water column, and each of the little bits around the rosette will be triggered. The Niskin bottles will be triggered to collect water samples in the column.
Okay, wonderful. ROV science control, you also hear me okay? Yeah, science control, all copied. Cheers, Ross.
So underscore should be clear.
So I'll give you a teaser of the other camera view. See if you can kind of predict it here. So not great, this stream, if people are made uneasy by either flashing lights or inverted footage. So.
Remote data storage on board the product.
Yeah, a nice explanation there. That the strobe is on one camera, and the laser is on a different camera system. They're running at different hertz rates, and then they'll get put together in post-processing.
So then that's probably why that's zero.
So should we review our project? Have it?
We can try it.
That would feel better.
Yeah.
Not spending 10 hours then.
We have to do stuff, and then maybe we can edit it. Hopefully we don't have to.
Maybe we can change our lighting to
Oh, yes, this thing, maybe.
We're just striving to be even more UFO-like as we cruise around off the bottom here.
You could probably.
Bash old. Yeah, just put old.
Yeah, there's been lots of little cat sharks, lots of little chimera ratfish. A fantastic octopus right at the very beginning. So again, if you're just tuning in, really can't stress it enough. Very cool octopus. go check that out at the beginning of the dive when you have time.
This is terrible.
With us being as shallow as we are, we don't really have much in the way of descent or ascent time. Just a little bit. So on the way down, we saw just a couple siphonophores. And then obviously the other day, we really didn't get an ascent stream at all because we were already pretty much at recovery depth. So we just had to go get ready right off the bat. And that may be the case for many dives this particular cruise. But we will try to bring you ascent where we can. It's always fun to see what we find.
Bridge, science control. Science control, bridge. Yeah, high quality on the radio, obviously couldn't get through there, so still got issues with the radio. We're ready to go, and if you could ask the winch operator to get it in the water, get that to 10 meters.
Copy that. I will do so, and yeah, I tried to apply. Thank you. ROV bridge.
Go ahead, Rich.
Yeah, you happy for the CTD deployment?
Yeah, happy to deploy.
Thank you.
Too quick.
All right, so you might have heard there in the background, we are getting ready for that CTD deployment, which again is going to be off the opposite side of the vessel. And so we have tracking on both of these. We have tracking on the CTD. We also have tracking on the ROV. We know where the ROV is. The pilots know where the tether should be on that. So we would call this a two-wire operation. And obviously, one of the risks of a two-wire would be entanglement. So that's why we want to know where both things are.
Science control.
Science control bridge.
Do you know how to make the wipers work on these cameras? Because I don't.
F4.
Science control bridge.
All right.
Copying the.
So there you can see the J-frame swinging out.
Yeah, I'm just trying to get to the. Yeah, got it.
And that'll cut us back on over to this view, which will slowly make sense. Very slowly. Actually, I'll come back to this. It's just a real nice shot there of the J-frame with that CTD and Niskin rosette. And now back to our other camera, where you can see things becoming a bit more clear. So you can see the lids on the Niskins. So the Niskin bottles all around the edge there, they are open on both the bottom and top with these spring-loaded lids. And so as we're in the water column and we want a sample from a particular depth, we can trigger a particular bottle to release its lids. They're spring-loaded, so they just snap shut. And that's what we have. And there it goes into the water.
Then the plan would just
Probably not
log
CTD in the
right
water.
away. And it doesn't allow you to do anything else. Yeah.
So it should be on this computer.
Yeah.
So we should see it.
It says enable You just need to mimic the name. You know when you were like
Yeah,
the data?
just why there was only raw.
Yeah.
Which operator signs control copy that to you. Winch operator signs control, please bring the CTD back to just below the surface.
So you can see the CTD right there. So they're just getting all set up. They're going to bring it right up below the surface, drop it down to set depth, and then at some point we'll be handing over control to the CTD computer, which will run the winch system.
Operator, please. Which operator signs control, copy that CTD just below the surface, please pay out to 100 meters at 30 meters per minute.
All right, CTD's headed down to 100 meters. So roughly a fifth of what the ROV is at right now. So although this kind of looks like it's stuck up in front of us, it's actually out at a decent little angle here. I can pull over the footage from that for you. So we don't quite get all the way to the bottom of frame here, but you can kind of see how it is stuck out and pointed down, sort of at an angle. And then the system itself has a pretty wide angle on it. And I believe the mount that's on there is actually set up with some degrees of setting on it.
It's got several set angle on
Yeah, not that we can like change on the fly, but this is why we would kind of scope an area out and say we want to map this area, map that area, and then we can set the little arm to the angle we need. Okay. And it doesn't look too steep in front of us, but if I cut over to our downward-facing situation cam, oh, actually, not that one even. I'm going to do the HD cam that's downward-facing. You can see right below the sub, it drops away.
So we've got some confidence surveys coming in as well.
If you're just joining us, this is live footage from the remotely operated vehicle SuBastian. You'll hear us just shorten that to ROV SuBastian, or just SuBastian. But this footage is coming from just shy of 475 meters below the surface of the ocean off the Galapagos Islands. This is dive 578 of SuBastian, and our second dive of the vertical Reefs expedition here in the Galapagos. This is the first dive where we are trying to integrate some new mapping equipment for the science team here on board. You can see that in front of us. We've got this,
We'll take control, thanks.
this odd little mount.
Can you hear me or not?
But with that integration, this being the first time, we are just trying to get all that working smoothly. So please have some patience with us. It does allow us to just sit here. And we've seen a couple cool critters this dive. For the rest of the dive, once we get this equipment going how we like it, we won't really be able to stop. We just have to keep going, keep cruising, keep scanning, keep mapping. Also, if you are just joining us, this equipment flashes a lot. If you have a sensitivity to flashing lights, when we get it fired up, it will be going. Yeah, we're going to just kind of be cruising. So I've referred to it as highway bingo a couple times, where we're just going to see stuff kind of go past and we'll be like, cool, we saw that. But we probably won't be able to stop and get those glamour shots for you on this particular dive. All right, so while we're waiting to get started here, we've got Dan over on the watch lead seat, and just going to have him kind of talk a bit about the systems we have here and what experience we might be looking for.
Thanks very much, Alex. Hopefully you can hear me okay? Yep, okay. So this is Dan Fernari from Woods Hole Oceanographic, one of the co-leads here with Cat Robert on this expedition. And you may be wondering why it's taking a bit of time to get things sorted out. High-resolution imaging of seafloor terrains is something which we are keenly interested in and very reliant upon now. This is something that really has happened mostly within the last 20 years, and in terms of very high resolution within the last 10 or 5 or 7 years. We're now able to image the seafloor basically at the same resolution that we can image a terrain on land using laser line scanning or other types of imaging systems. And it's a technology that, when applied to the ocean floor, has been really revelatory. It's opened up all of our sort of perspectives of the spatial relationships between different features on the seafloor, and that relates not just to the geological features, but also to the biology which are living on the geology, if you will. So, high-resolution imaging of seafloor terrains is really pretty crucial today in 21st century oceanography, and while it may sound simple, oh yeah, great, we're going to get a 1 meter or a half-meter resolution grid of a seafloor terrain, the details and complexity involved in doing that are pretty enormous, and it's pretty amazing that this actually works, because you have to have lots of different systems that are working in concert. You have to have the specific imaging system, whether it's the laser line scanning system that you see in the middle of the image here, with the high frequency, the 700 kilohertz multibeam that's on the end of it, that little sort of black thing at the top of your screen. But that has to be combined with the vehicle attitude, meaning not that it's happy or sad, more that we know its position in 3 dimensions on the seafloor. And that's done using an inertial reference system and an acoustic Doppler current profile, or an ADCP. And all of those things have to work together, and you have to have them synchronized in time, because as you're putting out pings, whether it's of light or whether it's of sound, you have to know what your vehicle attitude is, meaning whether it's tilted one way or the other, or forward or backwards, because that's going to put those pings in a specific reference frame. So having all of these things co-registered and working together takes some time, and that's what we're doing right now. Is we're taking the time to make sure we're in good calibration in terms of the sensors themselves, and making sure that we're getting all of the data streams that are coming up the fiber optic cable synchronized, so that when we go to process the data, it is meaningful, and we can produce these very, very high resolution maps, in this case of the vertical structures where the corals are living.
So I guess that kind of brings me to a question I had then for you. It was mentioned in chat that these same systems have been used for mapping shipwrecks and that sort of thing. Do you have experience with mapping, and what have you seen this sort of stuff used for, obviously beyond just these cliffs now?
Sure. My research largely focuses on seafloor volcanic and hydrothermal terrain in many different parts of the ocean, most prominently in here in Galapagos, where I've worked for about the last 25 years, but mostly at the East Pacific Rise at 950 North, where they were on the last, not on the last leg, but 2 legs ago with Monica Bright. And so we've used an autonomous vehicle, the AUV Sentry. It was told to do high-scale or high-resolution, large-scale mapping of probably the largest piece of ocean floor that's been mapped at 1 meter resolution. It extends for some tens of nautical miles, so some tens of kilometers, along the axis of the East Pacific Rise from about 9 degrees 45 minutes to about 9:55 minutes. So we're looking at that because we're trying to measure the terrain, quantitatively what the relief of the terrain is before the next volcanic eruption. That's a project which is funded by the National Science Foundation, and my colleagues and I, Ross Parnell Turner at Scripps and Jill McDermott at Lehigh and Thibault Barret at the University of Bergen, we're working together on that project to get a better understanding of what happens when you have an eruption and it repaves the seafloor. And you can only make quantitative assessments of that if you know what the terrain was like beforehand. So that's what our objective is in that particular case. But I would say in general, whether you're looking at the East Pacific Rise or axial seamount or the Mid-Atlantic Ridge, or in this area here in Galapagos, understanding the meter scale or sub-meter scale resolution of the seafloor terrain has enormous implications for then understanding the sort of biological phenomena, the chemical phenomena that are going on in these seafloor environments.
Yeah, no, we were talking. I was on for the Monica Bright expedition, and just talking about how the terrain can change there, and looking at some of the high-res maps that have been made of the area. And so the technology is fascinating for getting that glimpse of geographic changes, I would have to imagine.
Yeah, and we provided Monica and her team with all of the maps that we had made. So you folks, when you dove at the East Pacific Rise, had the advantage of having all of that high-resolution mapping all done, and you could just go right in and dive into the, if you'll excuse the pun, dive into the problems where, and go directly to the specific sites.
Yeah, very useful for planning the ROV dive itself, because you could see these smaller features and you could target them for the dive. You could say, oh, we're going to go over here and look at this feature, and we're going to go over there and look at that feature. Yeah. And in that particular case, the other reason why it's pretty crucial is you have a very small area, that the axial summit trough, the plate boundary of the East Pacific Rise, where the Cocos and the Pacific Plate are spreading apart at about 11 centimeters a year. That small little rift is quite narrow, from anywhere from 30 to 40 meters wide to maybe 60 to 80 meters wide. And so it's a really sort of small area within which a lot is happening hydrothermally and volcanically. That's the primary locus of volcanic activity and diking. That's is where the new lavas come out when eruptions happen, and a place where the hydrothermal systems mine the heat from the magma chamber and from the dike rocks that are hot, that are continually being replenished through the sort of heat exchange process that occurs through hydrothermal processes at mid-ocean ridges. Yeah, and I know, actually, speaking about that diking then, you were, when we were approaching this sort of crescent seamount that we're on now, there were ideas that we had like some that diking in the middle we could kind of see on the map, and we collected some rock. We collected like that big slab of rock. Did you get a chance to look at that at all?
Yes, absolutely. We were able to cut it up yesterday, and we had 2 rocks which absolutely look like dike rock. They're very dense, very fine-grained basalt, sort of a diabase-like rock. And so I would surmise that our interpretation is pretty correct, that ridge that we are sitting right in front of now and that we surveyed and sampled yesterday is in fact one of the sort of internal sort of plugs or core dikes that fed the volcano as it was building. We rarely get a chance to look at the innards, if you will, of a volcano. unless it's sort of faulted and sort of slumped off. So in this case, that rock will be quite important and interesting to compare with another sample that we have of the northeastern or the northwestern sort of part of the crescent.
Right.
And in addition, one sample is quite vesicular, and so that sample probably is something that is more of a late stage eruption and part of the window dressing, if you will, of lava flows that have built up the sides of the volcano. So good diversity of rock types from yesterday's dive.
Yeah, that's exciting that we were able to get that sample and then for you to be able to look at it like that.
Right.
I'll actually put up just for folks who are kind of following along. We'll put up the map here real quick. Let me make sure we got a pip going there, and I'll try and zoom out so you can kind of see the crescent shape a bit here of what we're looking at. And so you were saying kind of this area here in the middle, which is where we are. That's the dike area there then.
Yes, that is most likely a sort of internal sort of plug.
Wow.
And the resistant rocks of the dike are more resistant to erosion, so they are the last things to sort of get erased, if you will, by the current actions and just the sort of general erosion that takes place over time. And we have been able to make a new map using the Falcor 2's EM710 system, the shallow water multibeam. So the resolution of those data are about 5 meter pixel resolution, which is great. It's improved by about 3 times the resolution that we got with the Atlantis's 124 system. So we have it's not quite at 1 meter, but it is very good and gives us, again, a much better way to assess and plan for the kinds of mapping that you're seeing here happening on the screen with a laser line scanner of the places where we want to map in detail at a centimeter or even less scale, the vertical cliffs where the corals are living.
Yeah, and I guess, that kind of brings it right. Like you mentioned using Sentry, which is an autonomous underwater vehicle, an AUV. Yes. And that's great if you know there's like a seamount or you know there's a structure and you're just like, just get the whole thing, just map it all. But we have this mounted onto an ROV, right? I mean, we're actually going to be steering the mapping here. And is that just better for, it seems obvious, but is that just better for just drilling down really tight on one specific area and being able to visually target?
Sure, that's part of it. The other part of it has to do with the frequency of and the types of system you're using. So the higher the frequency and the closer you are to your subject matter, the higher the resolution you can get.
Sure.
The mapping that we do from Sentry to get a 1 meter resolution bathymetric map with about a 400 kilohertz system is at about 50 to 60 meter altitude. Here we're just maybe a few meters to 5 or 6 meters away from the outcrop, and this 700 kilohertz multi-beam ought to be able to give us centimeter resolution, and the laser line scanner even better resolution.
Yeah, they were speaking about, if we got a coral or something in that laser line scanner, we should be able to see polyps on the coral.
Right, exactly.
Okay.
Yeah.
So yeah, Sentry just doesn't get the proximity to the site that you're looking for.
Well, it's that, and it is a question of aerial coverage. I mean, in the case of Sentry, we're looking to survey kilometers, several kilometers square of seafloor area, and while it can do a pretty reasonable job of imaging steep terrains, it is largely a down-looking, focused multi-beam system.
Yeah.
Here you can see that the array that the SuBastian engineers have designed to put the laser scanner and the multi-beam on is this arm that is sort of at a sort of an inclined attitude towards the terrain, so that it is doing that imaging at sort of an optimal incidence angle.
Yeah, you can kind of see the angle there for folks at home. And again, we said we're able to adjust that angle before deployment. So we're going to scout sites and sort of figure out what's needed and then be able to approach that. Because, it's different from, like you said, Sentry's top down. Obviously, ship sonar's top down.
Right.
So to be able to get next to a cliff and get it scanned from the side seems very important for understanding them. So.
Yes, exactly. Yeah. Okay, well, anyway, so just to give people a sense of why we're not moving much, we're still getting well set up, because it's important when you collect these type of data to make sure that you're all set, that everything is well co-registered, and you're getting data into the right parts of your data recording system so that you have it when the survey is over and you're doing the laborious process of putting all of these bits of data together. So that's what we're looking forward to.
Yeah. Sometimes it's a waiting game. But I mean, we've been able to, integrate these systems on the ship and check like, yep, power's on and everything. But then you get down here and you're trying to get it dialed in, and it can be a process. Yeah, and I do think also that it's, while viewers around the world are looking at this, and they, I think, to some extent take it for granted. This is, of course, what we can do these days, and it is pretty amazing. A lot of it has to do with the people. So you've got to have really great people, dedicated, who have expertise in knowing how to do this and to fixing things on the fly, because there isn't any, there are experts back home, but we need to have resident experts here on the ship. So that's a really important part of oceanography these days, is having great technical expertise, dedication, and to the mission, and that's certainly what we've got here on Falcor. Yeah, it's kind of goofy, because we always have a different science team on. Oh, there's our laser again. We always have different science team on, and so they're bringing different equipment, they're bringing different knowledge, and then our MTs, our marine technicians, are having to interface all that. So the marine techs just pick up a ton of different systems.
Yes, exactly. Yeah, no, it's and you folks are doing a great job, and it's quite challenging, and we're very grateful.
Yeah.
It looks like we've got it fired back up. So again, for anyone watching, there's going to be this strobing light for a lot of that, but. Thank you to Dan for that fantastic explanation of the systems.
Okay, well, we were recording data. We just okay, well, now we only have X, Y, Z.
All right, so they have the laser up there, or they did there for a moment. They just turned it back off. But yeah, we can actually see the laser, and the system is going to be a bit darker. Because for these systems, it's a little better if we turn off the ROV's lights. Not all the way, obviously. Like, still gotta be able to pilot and everything and see. But we will be turning them down, so it's gonna be pretty dark. That being said, I mean, it's gonna be cool if something swims through the strobe. Made a reference earlier, right? That it's a little bit of Spirit Halloween. I feel like we just need maybe a smoke machine. And like a soundtrack of howls, and then we're good to go. Yeah, it's one of the interesting things about like the operations of Falcor Classic. This was a thing as well, and then Falcor 2, right? And we host different teams of scientists constantly, and so not only are we looking at different things, right, based on what the scientists are wanting to see, we're doing it with entirely different instruments sometimes. One team will bring on something like this laser scanner, and one team, is fully on like gas tights and that sort of thing. So constantly just like reorganizing the ROV, reorganizing the front porch of the ROV, reintegrating our systems, right? If you were watching for the Octopus Odyssey cruise earlier in the year, which part 2 of that is coming up in December, right? So if you missed out on the brooding octopus months ago, earlier in the year, you may have seen it pop up on the news. Maybe that's why you're here. Maybe you learned about us from some of that fantastic footage of all these brooding octopus down at these hydrothermal seamounts. Part 2 is coming up in December, so stay tuned for that. But when we were diving there, we were also looking for evidence of of flow, right, of these recharge sites, and then also where the water would be coming back up out. And that involved integrating this heat flow probe onto the bottom of SuBastian, and we would touch down in soft areas and like stab down almost like a little mosquito or something. We weren't sucking up anything, but we were measuring the temperature there. And so that was yet another system that just comes in with the science team that's on board, right? That's not a system that we just have floating around here. That being said, every once in a while, someone brings on a system for their own work, and we see it, and we're like, oh, this would be great just to be able to offer to other science teams. And we start, debating like, oh, could we see a more integration of that into our systems? Do we need one? That sort of thing. So constantly an evolving process, and the brains of the MTs just absorbing all this system knowledge and how to run these things and how to hook them up. It baffles my mind for sure. We are very, very grateful to everyone who makes these systems work.
It can. The recommended setting is 100, and I probably would have this.
Oh, I can actually show you here. Maybe, if I'm quick enough. They're looking at it. Let's see what I can pull up for you.
So that seems reasonable for right now. Laser scanning view.
So here is a bit of the laser scan view. So quite interesting, right? We get a little waterfall off of that. And a moment ago, they actually had pulled up the like a photograph from the system as well that had been taken. I'll try and get those up as we're actually doing the work. I'll try and put up the data that we are collecting.
Definitely not in this because when I hit it last night, it went anyway. And then I couldn't get it to come back, so I don't know if it's related.
Well, it's deeper than that.
Yeah. What do you have on 400 from the 7,000? It's a cool outside.
The laser camera exposure.
So in order to change that, I guess every time.
Yeah, because if it's power in the Ethernet can, it would be like this in the ground.
Well, the Ethernet constant is
Oh, the power.
Can we move a little tiny bit?
Can we move forward, Ben? Just a little bit?
All right.
They just want to move forward.
The moving underway.
Go down. Oh, you can go up, whatever is easiest.
Just a laser. If we go before that, he's backing down on the.
Just I'll pull up what we're looking at here on the waterfall, as you might hear scientists refer to it now and then. So there we go. That's what that laser is going over, right? And it captures the various details. Doesn't look like much now, but when it's all put together later, we're hoping for a real nice model.
We're undersaturated, so too far is what I think.
Too far, some below you. We gotta get a little closer then.
Oh, that's the laser. Okay, so
See if I can adjust that view for you all.
You can lower the laser we also have range filtering. Have to just disable the range filtering.
Yeah, that's not too bad. I was thinking that it might be too close, but it's. You can adjust that camera.
Did you just stop it?
Yeah.
Okay.
Sorry, I wanted to apply setting. I can't find it.
the concern of whether we've turned it off or it stopped working the way we anticipated. So.
Good to know. Yeah. Given you at least more of the other things.
So when did you get TSU4 right?
Okay, big boulder. We see it. I think we're still a little far. Oh, we're also
yeah. Let's hold that. Okay, Cal, are we close enough?
What's kind of so the laser needs to be with no closer than 1.5 meters and lower than 7.
All right, I'm gonna pull up a weird little kind of janky scene I just put together for y'all, but let's see.
Okay, so just visually,
There we go.
I would guess that we're within 3 or 4 meters of the bottom. And it's
Just for everyone at home.
Camera exposure.
Yeah, only that's up to the 100 feet water and good.
There we go. I'll shift it slightly.
Okay, we got a little bit more, so
And you can see the rules.
Fantastic, thank you.
so that was the camera exposure.
Yeah, so they have a
Can you look up on the right?
we've been able to do it.
1 millisecond to 4.5.
That's for
That's for exposed, that's the stills, yield is the laser.
laser. It depends. There's a table and it depends on the reflectivity of the material.
The only thing is that the higher you,
Yeah,
the sooner you have a
Everybody's flying back in.
So far, that could be
that's because you're closest to
too long. It has to only be that.
Yeah, but the only thing I would say is start making the exposure time too long, and then your laser's gonna snap.
Yeah. The red is over.
They wouldn't hold the ship long enough.
But we're saying,
just visually, I'm guessing you're not more than 2 or 3 meters from the subject matter from that slope.
would this be the altitude that we would be flying?
I'll be honest.
Yeah, you'll see me fiddle with this view as we figure out more how that data is going to be coming across typically. But yeah, love to be able to actually bring you the live data as it's being collected. For folks just joining us, we are hoping to begin mapping this area. So we are currently 484 meters below the surface with the remotely operated vehicle SuBastian.
Would this be good enough for the airplane?
We're undersaturated. Meaning we're not getting a whole lot back.
We've got a little bit of a watch change happening.
Do we have the art lights back down? Yeah, because we're not seeing the light anymore. Can we? Yeah.
We're thinking that the laser might be happier with less light.
So we're going to have Adam jump into pilot seat, and Chris just stopped in next to me, and co-pilot.
Make a difference or not?
Oh, there's one of the photos. So yeah, it's going to be quite dark for a lot of the dive as we just cruise around with our lasers and strobes on. We just need some synthwave music in the background.
We moved a little bit closer to the
Yeah, so I don't know.
I don't know, it's some sort of connection between
The two, yeah, you can't go fast.
Like in the SitCam view right now, you can see that stark differentiation between even our minimal lighting and no lighting.
No.
like that, right? So
Doesn't seem to make much of a difference.
you still
To be able to fly with a water crash.
That's all right. You can see it. You can see it. It's a blanket about 2 hertz.
The major power is 100%.
Yeah.
Okay, how about now?
It's getting better.
Just note that that's laser intensity based on reflection.
I guess it's not very reflective, I believe.
Camera exposure.
Was that what that was? Yeah.
In my head, I'm like,
How about now? Better?
Compared to like
Any better?
it's better.
Okay, well, he's
I just turned on
he's moved.
the
I'm
ram light,
guessing
so it might
a meter
affect it
and a
before
half.
you know it. Turn it off. I just turned on another light.
So like there's a ridge, that ridge is coming up real nicely and
it's quite important you don't fly into it.
yeah, don't
But it's true.
So let's say we might have to live a little undersaturated just for safety.
That looks a little greener than the
Yeah, like the
before.
ridge, whenever we hit that ridge,
Yes.
it's happy, very happy. But
That's that little nose that's salient that's coming out of the wall.
yeah. Okay. We'll have to live with that for now. So should we try and get to that first waypoint?
Can you set the level to the boat?
Yeah.
Do you want to keep doing this in the meantime?
Is there a problem that keeps the laser on longer than the
I don't think so. No, and the point of the patch test, we need both on for the patch test.
Hold on.
Right.
He's just
Can I minimize this?
Oop. Yeah, I'll have to keep hopping back and forth.
Yeah, it's just keeping back in the shutter.
Whoa. Oh, yeah. You're in between the blinks.
Nice.
Yeah. Okay, so to give you an idea of what just happened here,
So for the multi-beam survey, we'll
they just dialed in
turn off the
our upper camera,
but for the
so you can still see the laser, and you can still see the strobe on our main science camera. But on the sit cam, they dialed in the shutter speed to be in between those.
Yeah, that's pretty good. Can we do this on this though?
We could try it. I don't know if we're allowed to do that.
All right, we'll see if we can get that going on the
sorry?
side cam.
Are we at the first one? Sorry?
Maybe 160?
1.7? No, I think we're up the slope, so that could be
Oh,
really
150.
pitch.
Yeah, because that's what the thing itself is
That
at.
might be too. That's going to be too steep for a pitch.
Zoom in, sorry. A little bit more, and then just go down. Sorry. Yeah, we're trying to see where we are with respect to the waypoints. Yeah, go down.
So we're at the
We're
top.
up there, yeah, so drag the whole thing down.
They're currently attempting to synchronize the side cam as
I
well.
want to see the map. So drag the whole map down. No, you're going up that way. I want to see. Yeah, I want to see the vehicle basically. Centered.
Okay.
And then zoom in. All right. So yeah, if you want to be at 7, Kat. I'm sorry, 7 is so 7's there. Right?
7, yeah.
Okay. So those 10 meters.
25 meters away.
Is that
25 meters away.
right? Okay. So can you go down to the you want to east southeast?
Which
7.
7.
East, seven. Yeah.
It should be flat-ish. No, go ahead.
Sure.
Yeah.
You want me to get you something or?
Can we,
Yeah.
You
Can
guys
you
can
get
do it.
2 plates? One for me to okay.
It's closer.
Bring your, there you go.
what orientation do you want to be at 7? Facing 8?
Sorry.
What heading?
You want to be facing from 7 towards 8? Is that correct?
I'll be very honest, I wasn't involved in
I'll line up because I think we're doing a patch test from
Yeah.
7 to 8. So I'll just line up that way.
Yep. Yeah, no, go ahead.
It's not horrible, is this?
No, I'm trying to. It's too much.
So what kind of depth do you want to be off the bottom?
I think 4 meters, I think.
You're back. The question was, is the touch test from 7 to 8? Yeah, for the roll correction. Yeah.
And then 4 meters off the bottom?
4 meters at the bottom or the...
All right, it doesn't look like we're going to be able to get the science camera synced up right now. But SitCam, synced nicely.
Okay, that's us at 7, 4 meters off the bottom, facing 8.
Recording. Not yet.
Yeah, just make sure. I think I'm in INS. Oh, position
On that part.
It's
So roll stab at roll. Sorry? Or roll.
If not all of them, it's admittedly.
Okay.
I'll just split.
Wait that down as well.
We're way.
I think that the terrain has
Yeah. I think we might have to fly a bit lower.
200 feet, 3 is the new 4.
Yeah, I think so.
So we can use the altitude as a rough reference.
Yeah, because
Far away.
yeah, it's also the laser is a certain amount higher than the altimeter, so it's probably more at 5 and 4.
Because we're
Also pitch, but still like 35 there.
okay, that's 3.
This is a test dive.
How's everything coming through there? For the most part?
Multibeam is looking.
Yeah. So from this, we can actually see how far the dream is at the bottom.
Okay. So less than 4.
But also those
And it looks
great, but I don't know if that's
so that
there's too much going on. Also, the recent
So that was in INS.
Yeah,
Yeah, they're all the same, right? I don't see
reconnect
PSC4,
the
I don't
essential
see
phenomenon.
Delta.
that's I don't see Starboard.
Yeah, but I think the time
Yeah,
is
that's for a moment.
it's
I
like
don't
perfect
know what.
moderate.
But I don't see Starboard on
Flash it on.
100%. It's, yeah. And it wasn't last night.
No.
What bridge?
Yeah, let's
You wish you wait and see who's on there.
oh, right.
They're over here.
Let's run an asking what those people that because maybe we can't be able to see.
Go ask him if he wants to use their vessel in the same position while they're flying for like CTV. And if so, that's what they're going to really want to speak is that
Lower.
he wants to wait for a little while. Say that it's okay. If you want to keep doing recognition while they're playing CTV.
I think they do put the
Okay, so whatever.
Do you have
that or
Do you have to?
All right. So now that we have the gear
The
working,
issue is
the pilots are currently just
it's the same phone that she's
discussing with
using
the
for the phone
scientists
that
about the
it's not set.
overall plan.
It's not separate. You can't on the same PC. You can't do it at the same time. The same phone.
Okay. Okay. But mine aren't as necessary as the multibeam thing because we're. I thought that was the navigation was for the stills, right? The structure. Geometrization. I think we don't really. Yep.
So, Kat, are you thinking that our lights are affecting Norbit?
There's definitely, I don't think it's the reason for us being low, but yeah, it's definitely recommended to lower all the external lights.
Hold on.
So what do you got on now? You got on...
I have on just the foreground. Yeah, but I don't think that's good.
Just lower your resolution.
Yeah. So I think if you feed the ball in this point, it does the beam steering, because if you roll a lot in this direction, and by the time you record, you're like that. But if you know this.
Yeah, no, I'm just trying to think of if there's another way I can try to source the same.
We can go
yes,
without.
yeah.
We can try without.
Okay.
See what it does to the data.
Mm-hmm.
It might not be the prettiest, but this is kind of trial.
Yeah.
Okay, I'll take it off for now. We'll still be able to do the overall patch test.
Yeah.
And
Because I can try to figure out how to cut it from that and then re-import it on a different COM port.
Yeah, just run the last go straight, just to get us.
Let's
So
get started with this while you think about that.
Yeah. So just
70 meters.
and then can we just double check for her on her program? Is that still open? Or is it?
On Cat's program.
Yeah. They're both going. Yeah, voice.
Yeah. That is still going.
Where is the position? Was it under status maybe? Setup here. And then navigation parsing. So yeah, no, I'm just making sure that it's still updating because you tried to pull the COM port, so I wanted to make sure it didn't drop out. Yeah. So that's good. Okay, let me see if I can do something about
Blue
getting
is
another
too much.
TSS to you and another factory.
Yeah, blue is bad for you too. Not bad for.
Okay, so blue is too much. We have too much exposure. Yeah, we have to lower this.
Right. They said he's fine with that. It is sinking. Okay. Sweet.
Desktop is in that process up to 90. How much added? What's the distance from us?
So, if you want to estimate how far you're from the bottom, you can actually see it from the multibeam from the side scan, the first return. So if you want to estimate how far the multibeam is from the sea, you can estimate it from this.
Okay, so you're 2.5, 3.5 meters in.
Yeah, something like that.
Okay, so that's from the head down,
From
and that's what you're looking
head
for.
to the seabed. Yeah.
So do you bring it up to 4?
Sorry?
Did we bring it up to 4 based on this?
How far do you want to be up the seabed?
I want I guess the laser, so I guess the multi-beam 4 meters. I think I was actually understanding it backwards. The multi-beam were the laser where we got too much exposure. So blue is too much exposure.
You want to go
You
back?
actually have to go higher because the laser lower than the Norbit, right?
The laser is...
But it's good that the
Yeah.
the laser's lower.
Yeah, so actually the laser is even closer to the seabed.
That's what you want.
Is that what we want? No,
Or
we
you
want the laser at 4
Do you
meters
want me to kind of
altitude.
overcompensate? Because then if that's 3.5, if I come up to 4.5 on the Norbit, you think maybe the laser's at 3.5?
I think that's fine. I think the laser really is as close as possible.
Okay.
So long as we don't
Hit anything.
hit anything. And obviously we get less swap, but
Yeah.
we get more resolution.
And I mean, once you start flying, it's gonna be once you start flying, it's gonna be a
Yeah, we're
changing
just
game
gonna
all the
have to
time. Anyway.
like manually just as. Is there on the Norbit? Is there any way to bring that number up and just make it a little bigger so we can use it as reference, or is it just that scale? You can crop it, man.
Yeah, you don't want the stuff on the left.
I wonder if you go back to that menu in the Norbit, if you can crop.
Pretty girl, did you get that mode?
You know how you got like your fan range here?
Yeah, look at that, guys.
Yeah, you could crop that in.
I can crop it slightly.
The problem is that this is the one computer where we're running the two systems, so usually that part of the screen will be hidden.
That's okay.
Do we turn it off?
Okay. Yeah.
Well, I can crop it and put it up there. Because if I just crop it in that corner, like, it'll stay the same size. It's just gonna, there just won't be anything else around it, you know? Because the top and bottom aren't really getting cropped too much. But I can put it up on, I could just put it up on that screen over there.
Let's try it.
Okay.
You know which part to crop? Like that bottom. Like it's almost like a scale. It's got 10 and 10 on each side, and like kind of where the multibeam is.
Maybe.
I think that's the only way that we really get a feedback on that day.
Yeah, because that multibeam software is very basic. Yeah. And some of the other softwares you get the central beam and stuff like that.
Alright.
What part are you on?
So it's not on this big, but
Yeah. You want literally these numbers?
yeah, but all you need to do is kind of go from like 7 to 7 or something like this.
Yeah. Okay, let me see what I can do here.
Yeah.
Just getting the screen set up for the pilot here. They want to be able to see their sensor data as well as they're flying along.
So that ground faulting back then?
Yeah, but then Chris shut off the
Warning, we've been trying to find it and it's real random, so hopefully
yeah.
it'll come and go, come and go.
Well,
That whole thing's right though, it's mostly canvas. So the only ones we didn't
No, it's not. It works at all.
I'll say this.
I think it's no, because you got to go up. This right here.
INS, USBL. Sonar, compass, lighting.
Bam, bam, bam.
You probably can't turn off the forward lighting, right?
No. We can't turn it off. So we can turn off all the lights to forward.
Last time I did this though, when I killed the INS on that. And that's the
The
other
other thing we didn't turn off is the INS can do it.
We don't have any lights to forward.
And we also didn't turn off the. Other than that, we turned everything off.
4K cams on that.
That's for sure.
I know, but we had it like so we had
It's because you just turned it on outside of the synchronized window.
We still trying to get rid of the
green's good, right? Yeah, green's good. Water, we love that.
Yeah, this one. I just hit it by accident. Lucky. This is
screen a little bit, and then you just.
Yeah. So the sit one we were able to do at 160. And it just changed it.
Well, the other thing is they changed the first of the lights. Actually, that doesn't look like change.
It's over here. And with it's all over on this one. So get it.
Roger. The yard didn't beforehand. I know we're still kind of setting up.
Yeah, I just moved from 9 to 7.
Yeah. Alright, do you think we're are we good to go? Are we good to go? Let's try it. Okay. Try the roll calibration.
So can you just move it a little bit over so that you get both sides of the range?
Okay.
And then I'll know where I'm at. That's pretty good though.
Okay. So what do you need?
So kind of like this.
Yeah.
That. Okay.
So I
Okay.
can see that like maybe 7 to
Yeah.
7.
Okay.
Great service. In Ontario service earlier.
What's that?
Oh, they can like fatty light on it.
He's gonna drop the screen so
Water,
that you
so
can see the distance. See how you see the edge of the purple goes around? And that's about 3.5. That's
Is that far enough to the left?
yeah, that's pretty good.
Okay.
Then the Norbit is 3.5 meters from.
Yep, don't like that resolution.
There was no pasta. It was just salmon. Salmon, rice. Salmon.
Yeah.
No.
He just dropped it. Yeah. Hey, Cap,
Yeah.
could our sonar be interfering with yours?
Maybe you're broken.
No, we don't have that. We got a tripod.
Phone.
Yeah.
I would turn it off.
Okay.
Yeah, what's the frequency of your sonar?
It's off.
It's off. Yes. Okay. Alright, well.
It's probably more 500 kilograms.
Yeah.
Adam, does that work for you?
Yeah, that looks great.
Okay, that's about as best as I can get it.
Recording on the.
Yeah, we're recording all that.
Okay, I think we can try and fly that first line to 8.
Okay, so just dead slow kind of thing?
Speed? Yeah.
Sorry?
What speed?
Uh.
A tenth of an knot?
Yeah. 0.1.
Just slow.
Short slow. Yeah.
And we're going to try to keep the head of the sonar at 3.5. Alright?
Would you be able to announce the start and the end of the line?
Yeah.
Okay.
Are we able to turn on one more light?
So
or is that
once we disable the range gate, is when
Right now, it's actually because the right side is got that. Do you have some other light to interrupt that's not quite focused on that?
Yeah, we can.
Yeah.
So that, that's right. Just something to make sure, because we don't have the sonar now, so if you want to, this something. Yeah, that's.
All right, folks. Apologies for some quiet time there. We're just trying to get everything set up for the pilots and the scientists, so that everyone's needs are met. The pilots, so they know where they are. The scientists, so they are getting the data they're looking for.
Oh, I see where
because when it looks under
I think that's probably
Do you need it changed? Okay, I'll have to set it up every time we run this, but yeah, I saved the numbers at least.
Yeah, no, that's cool. Like the size of the box or whatever.
Yeah. We'll just have to redo it every time, but it's fine.
that's definitely blue. It's blue is fat, right?
Yeah, some should be ready.
Alright, that's better. And we can now get 50 laser profile with the range gate.
He's just waiting for you.
Alright,
to go.
let's do it.
Let's do it. So super slow, 3.5
Super slow.
meters.
3.5.
2.8. Here we go.
Alrighty, we are getting underway, nice and slow.
We should almost try using altimeter now.
Yeah, it's flat enough. So instead of back moving,
That altimeter at 3.5. Where are we on? Are we on the...
so it's that all we're on INS.
What was that, sorry?
Try to keep your head correct as possible.
Yeah. Yeah, we got our cutting it there.
When you're ready.
I don't think I can go that slow.
Alright, he'll go for you.
Okay. Yeah. 15 to 25.
That's your routine. You just get your turtle.
How much they have collect already?
Yeah, just with the testing.
Just with the
Do we know how much space it's taken?
Yeah, I mean, we put the time when we started.
When we said that called it success.
Do it again. I set it up.
Yeah, so you could potentially just use that as a marker.
134 gigs.
All right, so since we've been testing this system, it looks like we're at about 134 gigs of data for the dive.
Yeah, the rod is going to take 99 gig, yeah. Image raw.
So there's, you can see the images. We get all these little stills.
Gigs, but we'll run. Yeah, maybe we have.
I think we're starting to move.
Raw images.
All right. Away we go.
We were starting to move.
Yeah.
So now we're just looking for, the pilots are going to be maintaining an elevation, a heading, and a speed as we begin our great dance across the seafloor.
Oh, yeah. Yeah. After this one, we gotta come back on it from 8 to 7. Yeah. From the roll.
So you can see there, again, all the yellow dots are where we're going. Just kind of back and forth, mowing the lawn of a sort.
How's that speed go?
Yep, that looks fine.
What's the speed? What's the speed?
It's about 0.2 of a knot.
All right, going about 0.2 knots with our movement here, and this is going to be most of the dive at this point, but at different heights. So at some point we're going to be 50 meters off the bottom for the doing the multibeam. So yeah, sit back and relax. Just watch the seafloor go by. Lots of dots. In action, Chris.
So sorry, when we get to 8, if we're almost there, and you just stop, break the line, and we do a certain roll, and then we go back. Okay. No, that's something else. Yeah, right, exactly right. So when Andy, when you get to 8, let us know, and we'll call it a line, and then you spin to the left or right or whatever, probably the left, and then we'll want to go back, and then get us a start a line, and then we'll do the same thing. And I guess put the vehicle, middle of the vehicle at the dock, more or less. Just go ahead and say.
And there's your lovely view for
Okay, that's not
a lot of the dive.
Okay, so you're gonna. Okay, so that's the end of this first line. End of the first calibration line.
Turn. 100 copy.
turn and go on the reciprocal.
So can I tell you the full plan we've got, because really we've just got underway. So I can kind of tell you the variety of moves that we'll be making here. Just got to pull it up. So we've got to do some basically calibration flying. So just going over some flatter areas of the terrain.
So this looks like it's going to be a little different because it's going to be on the downhill now, right?
You are going to go down.
After that, we're looking at using the multibeam to do some mapping. So that'll be 10 meters up off the seafloor, which means that multibeam then, right, because it fans out below us. If we're up 10 meters, then the fan is covering 40 meters of the seafloor. And we'll just be doing lines north and south, which you've seen. You've seen some of those, I think, on the map already. And that'll be a couple hours. Like each of these steps is a couple hours. So it's going to be busy. Laser flying will be at 4 meters. And then if we have the time, we're going to repeat our 4 meter passes at 2 meters. So all said, this dive total time is about 24 hours. But a lot of it's just going to be this laser line.
More green? Yeah.
Yeah, I mean, I think for the really nice stuff, we'll have to get closer.
Okay, so it's probably
That's part of the testing.
Okay, so
That's good to know.
Is it okay if I show
okay, so
the
we're maybe
window
start a
so
line?
that they
Yeah,
can
yeah.
Okay, so we're going to start from the reciprocal line?
Yeah,
Okay,
you
you're
put it.
good to go?
Yeah, we're already recording.
Now I've set a line up a slope for the pitch, but it's massive rock, so I don't think we'll be able to come back down.
But actually, you could do a pitch calibration on factoring a big feature that they eject from the two directions.
And that's the thing for heading.
What is the
Heading to the vessel.
I believe both devices are running, but we have different flight paths and different needed altitudes for the two maps being provided by them. So the multi-beam will be getting done from about 10 meters up, and the laser will be getting done from 4 meters to 2 meters. So.
Well, it's easy.
What happens after this? Do you do it again with multi-beam?
No, we can do both at the same time, but we've only done, this is the roll calibration line.
Yeah.
So we were just discussing the pitch calibration line. For that, you need to go up a slope, and then down a slope. But I think that's too steep to be able to go down a slope.
Yeah. So yeah, just still doing the calibration right now.
Does this slope taper down and get a little bit more severe?
And meanwhile, while we're taking a look at all that, the CTD is still over the side. It's still doing its thing.
It's far, though. I don't know.
Oh, in terms of distance.
Yeah.
think it was more than 0.2 meters.
Sorry? I think when we do like proper scans that we're interested, we'll want to be closer. Yeah, so that's 4 meters. Yeah. Like,
Or we can like throw the CPD at 100 meters altitude.
We got.
Yeah, hopefully once this becomes more routine, we can snag some of the scientists and get them on the mic. Like earlier, we had Dan kind of explaining the systems a bit. Right now, they're all very anxiously just watching the data and making sure everything's still working. But once it's more regular, I think we'll be able to get some interview mode going on.
I mean, we can delete 99 right now.
Just kind of transit over tonight?
Yeah, so we need to find a slope that you're comfortable going sort of up and down. I have a feeling everything we've seen so far was okay going up, but a bit too steep to go down.
So,
Uh-huh.
I don't know. There's probably some. I don't know how exactly how far we are over here.
Oh, that's like
Just give us a little more light if we come up to the building.
At which point do you try to do 3? We're going towards 9.
Between 7 and 9. It's not on one of the actual lines, is it?
Yeah, you know, the weather's pretty good today. And we have seen lots of sharks when we were at anchor in Galapagos. We saw lots and lots of sharks. But just these little teeny black tip reef sharks, small. Very cool to see them cruising around. There was usually like 15 of them just hanging around, short little ones. Like 2 sea lions cruising, and then there's a pelican that would usually come visit us in the evening and just hang out with the sharks, not bothered at all, because they were pretty little sharks.
Where are we getting this? It's only morning.
So this is us kind of coming up on 9 here.
Okay, can we see and try and go to 10, and then you let me know if you think you can turn around and go back down.
So you want to do like a full scan 9 to 10?
Sorry?
You want to try a full scan 9 to 10?
Yeah, that's it. Yeah, we got to go over the thing.
Somebody was telling me they were
Line, but
So for the moment we've got something that's open. And
yeah, we got to run the same line, different direction on the slope.
we already have just
Okay, so. I mean, yeah, we can fly down. It just may not get a good image because it might drop off.
I don't care about the image. It's really just we gotta figure out.
Just taking a look
our lasers
outside.
Pitch forward, which
This is what
it
we've
is.
got.
Yes. Yeah.
Awesome.
Nice and sunny out. Let's see. Let's swing my camera around a little bit here.
Yeah, she broke on.
Oh.
Pretty good.
yeah to break it on you.
Yeah.
Nothing too bad. Doesn't look too hairy out there like it's gonna mess with our stream at all for you. But you never know. We run into problems all the time with it.
Okay, so
Just a matter of running around and fixing them.
Whenever you're ready. This one I can't put auto altitude on, so I'll have to fly.
Yeah.
I think once we're done the calibration, we'll delete all the raw. Give us some space. Then, yeah. I have 16 terabytes hard drive.
We have external 16 terabytes.
Yeah, that's
Like,
right.
the reason I'm wondering though is
Yeah, we'll see. I am curious, what we're going to start getting during ascents.
Okay, starting
as short as
9 to
they
10.
might be. I have a suspicion with these cliffs we might see some upwelling there, some nice nutrients in the area, and so perhaps we'll get some cool critters coming by.
I just wanted to see how much fun this would be for me. Yeah, I mean, it's a little bit less than 3 minutes.
We're recording, right? Everything?
Just right. And if you're flashing,
We're recording.
So,
and that's even, that's probably she's not going to record.
So that's right there. Where you're at.
Yeah, thank you.
This whole laser is also pretty low laser. That's what it's thinking. So it's maybe the image is that far.
Yeah, they're live. So you're coming up.
Yeah, but of course it's going to
So coming up to the slope here.
let me look at what we can do it.
So that's still about 3.5 away from the wall, as far as I can tell. But it's going to fluctuate because you're going to get like the divot here.
Yeah. Well, at least if we're at 3 meters, you know, even if we go to 5, we should still be okay getting data.
Right.
If we go to 10, then we won't be getting.
Yeah, okay. I'll keep it close. Yeah. Not uniform close. Yeah, that's 3.5 on the sonar.
Bridge science control at 100 meters. Wire angle looks okay, so I'm going to bring it up on manual.
All right, so you just heard the CTD is going to be coming up.
What's that? No, just heading.
So we'll kick on over here. And keep an eye out for the CTD.
See, this is where it's hard to kind of judge the distance.
Actually, I'll flip those around.
Say we're still. Yeah, basically. Nice, thank you. scale change in there? Let's just get the cropping is changing on the sonar.
That boulder could be a really good target for heavy detection. Big boulder there.
For what?
The next line we need a feature, so I could draw a line.
Do you want us to put a marker on it?
There is one basically.
We're pretty much at the waypoint.
All stations that speed get below the surface.
Visual on that.
Visual bit.
But first we gotta come back.
Do you want to go down backwards?
No, we have to flip it around, but you know what? If the really steep part is too steep, I'm pretty sure just that slope that we've hit since coming up is enough.
Okay. I think as soon as you get to that slope, it's just going to drop off and you're just going to be
we're
free
going to
water.
lose it, but I think that section we just did above the really steep was still a slope. So
right.
I think it'll be fine. That section.
Right.
This is at a slope down.
Yeah, so that's us at 10, sorry.
If we can just pass it a little bit and turn around. So end of line. End of line. End of line. Yeah, no. Sorry? Yeah, that's fine. Yeah, that's fine. The tricky part is we need to be back over this line.
Okay, I'm ready to
start of line.
All right. Starting a new line.
Complaining about price of so sorry, can we pause for a second?
Hold it.
Maybe it's just okay, we can start again.
You ready?
Yeah.
Alright.
Might be a little high once
Yeah, I'm coming down. I was just in the autos there. Okay, so we'll come down to... So this is 3.5 on the sonar head now.
Okay.
So, but it's obviously going to kind of be all over the place, so...
Yeah, I realized that scale kind of adjusts itself.
Yeah, so... Yeah, because... So before I noticed it was in 10, and so I was flying thinking I was in 3.5, but it was actually like 7.
Yeah, because because the seafloor was going like this, and we were losing some of the alpha beams of the multibeam,
I
and
see.
it changed the range, but then I hadn't realized that changed
That's fine.
the whole thing as well.
You just do what you do. That's,
Yeah,
if
but-
you have to change it, that's okay.
We'll give you a shout if you do that. That
Yeah,
might be
cheers.
helpful.
Yeah, the only problem is, so when it goes to 10, it goes into the Falcor F.
Yeah.
So I can't see what the scale is. Yeah. So you happy to start this then?
Yes, please.
Cool. Okay, here we go. So 3.5 and down to 9.
If you're just joining us, you are watching live footage from the remotely operated vehicle SuBastian.
Yeah, see there, see it's 20?
Sorry?
See the scaling now is 20?
I was able to get roll stabilization in,
Oh, nice.
but it's going back and forth because I think it's for the log rates. Another 3-1 or
Sorry, I'm ready.
yeah.
Still just waiting for that CTD to come up.
I think so. I think that's wrong. Well, I think it's just delayed, so it's not picking up any roll value. Yeah, for a second or millisecond, whatever it is.
Yeah. Because you're paying out such a high rate.
Yes.
Then have the wrong roll value. You know, those roll values, the impact of the video, like, that's gonna screw.
But isn't that just? I think it's just stabilizing it. But that's as far as I can do for now.
No, that's fine.
Okay.
Yeah, basically have the water in the ground. Yeah. So I see the edge there. What's that? Oh, there it is.
Not quite yet. Not quite yet. What's that?
I'm gonna change the range. Yeah, because relaxation right off like that. So now you're on 50 meters.
Alright, you get good view in your app camera and then put it behind you. I think that's 4.3.
Yeah, I gotta go forward here because it's multiple ones. Yeah, I see it. Oh yeah, the arms sticking out that direction too.
Should be good. Stuff with that angle. Weird.
Okay, that's us coming up on 9.
Right. End of line. Alright, now we need one last line for calibration. We need to find a big feature. So there was obviously that big boulder at the top, but there might be something closer to here that we could.
Yeah, we can go back to that boulder if you want to do that.
If you want, I can turn the sonar back on and see if it's got anything facing forward facing.
Sure, yeah.
Alright, I'm gonna turn the sonar on.
Yeah. Yeah, I'm still on a regulator too.
Alright, range 10 meters.
They go like 30 or something. I think we'll have to pop up the one over top of this cliff again.
Let's, I mean, we know there's a big boulder at 10, so it's
You want to go to there?
5 minutes ago. What did I see?
the laser. There's that right there.
There's that, yeah.
There's that. So we'd have to go, like, along those features,
Like
close
this?
to it. Sorry, it can be on, the line would have to go sort of, the thing is we have to be able to do it really close and then slightly less close in
But
the
then
same direction.
the line's going to be this way though, is that okay?
No, the line has to be across, something like that.
Oh, you can do it, you can change the line? Sorry. You just, so if I just come close to the wall here, like here's a boulder right here.
Yeah.
How's that one looking?
Okay, that one could work.
Yeah.
Okay, so we'd have to have it go over, like in the middle, and
Yeah.
then on the outer beams.
Okay, so you just,
In the same direction, so you can go over it,
yeah.
stop the line, back out, and then go over again.
Okay, so 2 in this direction.
2 in the same direction.
Okay.
Yeah.
ROV,
Okay.
trying to control that CCT in less than 100 meters off the water.
RV copy.
You let me know, Kat.
Adam, are you ready?
Yeah. Let me
Okay,
just get,
stop.
let me just get a little lower here.
You go individually into this one.
Okay, I'm ready.
Alright, start of line, that's heading 1.
Just a big feature calibration.
Yeah.
The heading.
Heading. You targeted this feature, right?
Yeah.
Okay. So go in the same direction, but different distance.
Yeah. Just, yeah, fully pass it. I want to make sure the sonar also passes it. So we're
Okay.
without hitting the,
Yeah, I don't want to go up
Okay,
any closer
then
than
end of
that.
line, and then if we can back out.
And then do it again, you said?
Again, but now we want sort of the outer, so we went straight over, so
Sure.
maybe if we can have the outer beams hit the edge.
Come this way then?
Same heading,
Yeah.
we just need to sort of lateral
Okay, so,
like 2 feet.
yeah, so somewhere like over here. I see what you're saying, yeah, okay.
Yeah, like if you hit the edge now on the middle, some of the features should
Right,
be-
so how about somewhere right about here?
Yeah. Yeah.
Okay?
Ready?
Yep.
Start of line 2 heading.
Sorry, I'm going to come back down a little bit to get the laser from the bottom. So maybe start somewhere down here.
Yep.
Here, you ready?
Yeah.
Okay.
Okay, that's our patch test.
All right.
Alright, so if we can move to waypoint 11.
So the pitch is included with what?
The pitch we just did, it was up to waypoint 10.
Okay, so we'll have to move the ship.
And now it's a multi-beam survey, so we don't have to have the laser on.
Okay, so end of
Yeah, so make sure Jim was okay.
This is as long as the heading doesn't change.
I would just give a heads up on the radio.
CTD ROV, we're going to move the vessel to the south a bit, just to let you know.
Copy that, moving the vessel to the south.
I think I just saw from here then, because we see the first and then the start.
Yeah, that's the color stop. Yeah, because that's our patch test or patch test. No. Well, you can start it when we get to the point.
So we're still waiting for that CTD to come up.
Bridge ROV, the new waypoint for you.
Yeah, copy that. I'll be moving that.
So you'll actually have to go quite a bit further because we're going to go 11 to 12.
Oh, we're going that far?
Yeah, 11 to 12, right?
So now, yeah, we're going to be going sort of, 11 to 12, flying about 10 meters off bottom. Now we just have the multi-beam.
Okay.
And when we get there, we're going to have to just get back down to 13 because we're going up the slope.
Yeah.
I don't think we can't map from 14 to 13. We'll just
Would it be
lose
better?
everything.
Would it be better to go from 12 to 11? So we're going upslope, or you want to go down?
No, it should be upslope. From 11 should be at the bottom and 12 should be at the top.
Ah, I see. Okay.
And then we drive back down to 13, record from 13 to 14
Right.
upslope.
Okay. And what's the slope difference there? Just a couple of meters?
Yeah, similar to what you just did at 10. It's about 10 meters.
Okay.
We're starting small.
We're just going to move the ship here, so we can see.
It'll put you at 68 meters from the goal point.
Yeah, sure.
You don't make it the laser now.
No, the laser will just do a
After all you did.
pretty high res multi-beam of the area. Black and white. We'll do the laser after. Yeah. Yeah. Much lower, 4 meters is too high, I think. For like 12 hours. Once we've done what's ultimately planned. Lunch.
Maybe get power from the kids.
I have a feeling it may become like podcast cruise when we're doing this. Once it's down to like a routine, yeah, just like slap scientist on over in there and just talk about it. Yeah,
Have a long,
They're getting power from the
long form podcast.
that's it. Yeah, 24 hour. No, Dan gave a great explanation earlier about the systems while we were setting them up and stuff. So it was nice.
That's great.
Yeah.
Do we need an explanation of patch tests?
Yeah, I mean, if you want to talk about like what we were seeing and what you were calibrating, you're more than welcome. We'll get you on a mic.
Alright.
I wish we.
Yeah, all the time.
Yep.
Hi everyone, online. So I've not introduced myself. I'm Cacho De Coral and I'm the chief scientist on this expedition. And you've probably been hearing me, have been hearing me talking in the background.
It was tense for a moment.
Yes, it always is. The first dive of any new technique is as you get familiar with the data streams and all the parameters that can change. So,
Yeah.
We got great technical support and probably problem.
I'm happy we can see the laser.
Yeah, it's
Which is
fun.
nice. Yeah, it's
you
nice.
can really see what you're scanning.
I could do without like the strobe, but the laser's cool.
Well, the strobes is actually recording stills, and they're recording fast enough that so long as we can see one feature in 3 stills, we can also do structure from motion reconstruction. So that's the same idea as watching a movie in 3D, but instead of having 2 cameras looking at the same object, we can do the same thing with a single camera recording 3 times the same object.
Oh, okay, yeah.
From a slightly different perspective.
211.
Cool.
Yeah, 111 too, yeah.
Yeah, maybe I'm making 211. Yeah, where it's 12. Let's see. 12.
Yeah, I don't know if you saw it earlier, but they were futzing with the settings on the sitcam.
Yeah,
and they somehow managed to get the frame rate like perfectly in between everything, in between the laser pulses and in between the strobe.
Oh, wow.
And so this screen was just going wild, but that screen had
It was
nothing.
totally fine.
Oh, it was great. Yeah,
Wow, that's delicious.
it was very cool.
12 hours of laser scanning will
Yeah, yeah.
What we wouldn't do for data, huh?
Yeah, it's gonna be cool. It's gonna be cool to see like the whole thing afterwards.
It'll probably take a few days to post-process.
No, ROV on deck. I'm gonna be looking at it.
Looking at it, yeah. We've already collected over 100 gigabytes of data.
CTD at 100 meters.
Yeah.
Wire angle looks okay, although the
Yeah, okay mate, we are moving at the moment. We're going to shift it south, so we're moving in the direction of the wire, so it might be worth waiting until we stop the move before you recover any cover.
okay, well I can bring you up slowly to 50 and we can re-evaluate there if you want.
Yeah, I mean if you're happy to do that, that's fine. From the immediate wire angle and the side of the ship, it looks okay to me.
Okay, we'll do that then. I'll come up to 50 slowly.
So there you were hearing our lead tech, who's currently bringing up the CTD, calling to the bridge and just kind of questioning the ship's moves at this time. ROV is moving, so the ship is moving to stay away from us. And we happen to be moving in the... Oh, ROV is not moving, but ROV is going to be moving. Chris was like, ROV's not moving.
The ROV's at the start of the line.
Yeah, we're waiting for the ship to move so that we can move. But we happen to be moving the direction that the CTD is. So our lead tech was just curious about all that. And then, of course, that was on a channel that we hear here in Mission Control because the pilots need to know what's going on with the CTD as well. Since we've talked about with these 2-wire operations, you want to make sure you know where everything is.
Have you mentioned why we're doing a 2-wire operation?
No, there was a question. Why are we doing 2-wire?
So we've got a CTD, so that's the instrument we use to measure current, depth, and temperature. That gives us an idea of what the water column is, what kind of water mass. So some water masses are hotter and some are more saline, for example. So that gives us an idea of that. But that changes with things like tides. So by doing 12 hours up and down of measuring the water column across depth, the temperature and the salinity, we can see how that varies. And why that's important for corals is because cold water coral, the food that they eat comes from the current. So that's different from shallow water corals, which use a symbiotic algae, like and use it. The algae just like a plant, it uses the sunlight energy, but then it shares that with the coral. In deep water corals, it's more like an anemone, so we have little tentacles that grab particles as they float by. So if there's not enough current, no particles float by. If there's too much current, the little tentacles get blown and they can't actually grab anything.
Okay, so I'm about 10 meters on the Norbit.
All right.
And
are we comfortable with ship position?
Yeah, he's almost in position there. Yeah, we can start. I think we can start
All right.
cruising here. So
Let's start multibeam survey.
what did I just say? Go to
Yep.
waypoint.
Okay, let's go with it. So let's freak out and try. Ready?
Pristine control and start at 60. Give us a shout when you've finished your manoeuvre.
Okay, that's nope. Hold on.
Can't tell if it's going too slow.
Was this 20 meters on either side? Yeah. Straight to 20 meters. The lines are 15 meters apart.
Okay, let's try. Yes. There we go. That's too fast though.
Yeah, go to see here. Turn up.
Yeah.
Are you here? One.
Okay, you ready to start this? I'm gonna back up a bit. Okay, so I'm back on 11 here. We're gonna try waypoint following here, see if we can get a real good stable.
Yeah, the more stable the better.
Yeah, so that's station key. We can turn this on. And we're gonna go 12. Are you ready to start then?
Yeah.
Yeah. Okay, this is us starting.
There it goes.
That's 0.3, 0.4.
Yeah, slow it down.
It's too fast.
That's
As slow as I can go.
One more time. There you go. One more.
Is it moving now?
You're going to 4 by 5. You slow it down.
You want to go real slow, right?
There you go.
That's too fast.
Ellen was commenting.
Yes.
And I said, I'm sorry you can be on board. I hope teaching goes well.
How is that speed too fast for you?
Sorry, 0.3. We can get 0.2 should be good.
Okay, so I got to get max.
There you go.
Well, I killed it. Okay. So I don't see how to jog that down.
Huh?
Do you touch the actual tool
Sorry?
instead of the cursor?
10 meters. Yeah, so
And you're at 0.2.
Yeah, it was 90 flight.
we try to stay around 10 meters.
Okay, yeah.
Right, with a large. Yeah. Rock. You're clear. You're clear. That's going to change you. Or take your depth.
Yeah, sound really good. Left side.
Yeah.
Just kind of.
There's a big flip. For this one, it's actually okay to be a little higher. It's probably better to be a little higher than a little under, because if we're too under, we won't. We'll have gaps.
Right.
Our swamp won't be big enough.
Okay.
Not too much higher, because anyway, but I mean, if the Norbit is doing fine.
How far are the lines between them?
15.
1.5, yeah.
Do you keep coverage?
have to like pull out,
Yeah,
but I guess we'll just have to.
we'll have to see what the data
Yeah.
looks like.
And so then we're gonna go back to 13 and do
To
this.
13 and then go back up.
Okay.
Alright, can I go quick?
Yeah,
We'll swap. Emmy, are you good?
Yeah, I'm thinking that.
So
Are we taking the
13
line
back
to
north
13,
after that.
or is this just a transfer?
What's that, sir?
Or,
13
no,
and
just
back
a
north.
transfer
Yeah.
back to 13, because you can't go down to
And which way do I turn? Port. Port. Alright. Port.
The same guessing game that we're going to do. Which direction is it coming this long? Alright, I'll move the ship back north, and if we're going to be there for a while, or we can come back down to 14.
I think we're in a good position. I think we'll just do 13, 14 like we did.
Yep, so then we're going to do that, okay.
Yeah.
Back down. Alright.
I think you actually probably don't have to move them at all.
Yeah, I didn't know if we were going to go to back up here. So it's going to be 2 big ones. Yeah.
All stations, that's the CTD just below the surface.
Already got
Calibration.
It's actually, yeah, it's up and down. Those vertical lines. Also, typically later on, get close to the seafloor, the lines and stuff. Yeah, that must be what it's the guys know that.
So we had chatted earlier on about getting an overlay for heading. How about for altitude? That would be super helpful, especially if somebody around the ball or another. Sorry.
That you want to, yeah. I think Alex is working on that. What the steps of that was.
Okay.
You wanted that on the overlay for the on the side camera, correct?
Yes. Thanks.
One of the sit there and watch for a while. I should go for the lines.
Oh, okay. Yeah, you should.
Yeah, no, you know, no.
Okay, that's me at 13, ready to start.
Okay.
Yeah, okay, start recording.
Start to the first second.
Okay.
All right, here we go.
Yes. And we're only recording one when we do the turns, you're not recording.
No.
No. It's got this. That's okay. Well, we just started one.
Massive hole.
And altitude?
Is it on 10? Yes, it's 10 meters.
How's that speed?
I know where the speed you agree with cut. 3 point, what is now?
0.2 meters per
is
second.
fine, yeah. I mean, I can see this.
Or I think it can go a little slower.
I can go 0.1.
Are you bucketing current or no?
No?
No, it's good. 0.2 is fine.
Okay. So yeah, this is where you get the discrepancies. As we come over the cliff, you go from 10 to 5, right? So.
Can I see your altitude guys?
What's that?
Your altitude.
Altitude is 8.6.
Yeah.
Okay.
That number is right.
Yeah, see, I don't go by that though. I go by your sonar on the edge of the.
Okay.
So it's like right now we're probably a little high, but of course the ground is like this, right? So you're kind of getting the average.
Yeah.
Got the port side on higher and starboard side lower. Yeah.
There's a question exactly what the Norbit is. What's that? There's a question about
What the Norbit is? It's a 700 kilohertz. Do you want me to chat in here? What, am I supposed to read what they're asking me? Or no?
Sure, yeah.
We had it up over there.
What is Norbit? It's more Norbit. Okay. Tell me what I'm supposed to do now.
You can just use that microphone and you put a headphone on.
Okay, can you hear me okay? Can you hear me all right?
Yes.
Yeah, there was a question in the chat. This is Dan Fernari, about what the Norbit is. It's a NORBIT for Thomas. It's a 700 kilohertz multibeam sonar. So it's emitting sound at a very high frequency, and that's what we're using to make the detailed measurements of the seafloor. We're now traversing the bottom at approximately 10-meter altitude. The pilots are flying these lines that are going pretty much north-south, and we're acquiring data, much like the ship's multibeam, which is mounted on the hull, does. It emits sound at a certain frequency and impacts the bottom, and you're measuring that time travel of the returns back to the sensor. In our case, what you see in the bottom of your video screen is that sensor that's sort of sticking right in the middle lower part of the screen. That is the acoustic head that's emitting the sound, and it is recording data that we are then going to be processing here in combination with the laser line scanning data. Hey, good enough?
Are we just trying transiting to waypoint 15.
Did you stop the line?
Yeah.
I think the line started pull at 5 meters. I think that cliff's getting higher on us. Did you record it now?
No.
Okay, hold on.
Maybe-
Did you already start the moving?
What?
Did you already
You
start?
on the line?
Hold on.
No, I'm just going back up to 15. So Kat told us we're just going down, then transiting down, and then transiting.
So you're not.
No, I don't record it.
Yeah.
Oh, I see.
the northern passes aren't being.
Oh, I see.
recorded,
She's just recording data on the southern. Okay.
Yeah, so just as we come down and then go up and then just down and then just transit back and then that's the conference. So.
I see.
Yeah, I'm just doing your delta as reference to your distance of the vehicle. And then I'll keep it a little bit more.
Is there a particular reason?
Yeah, you can probably suck in 5 meters because it's we're so close. I don't really even feel it.
I feel it's like to do with
I just get
400 meters of depth.
Yeah, I mean, I agree with you 100% on that. There's situations. I think 80 pages of vessel. That was February. You don't need to come down. Concentrate now on that. Got a job for then they say thank you.
That's cool.
I could do that.
You see the message.
Okay, so it looks like he's at the top of the line then.
Yeah.
Okay, let me start.
Yeah, go ahead.
Go ahead, Lance. Yeah. Just tell me when you're steadied up, Andy. Yes.
Okay. That's approximately 10 meters, so I think we're going to start now.
Okay, stop.
Okay, we're recording.
Yeah.
Okay. Okay. You had one, right?
No.
No?
No.
Well, wait, just go get, just walk in and get James. He's right in the lab.
Yeah.
Tell him what to do.
Yeah. I've only got a couple of these left, so I'm happy to transfer and get it done.
What's this, those boxes are what, 5 meters?
10.
10.
feature there too.
ROV, science control, that's the CCD less than 100 meters off the bottom.
Science control. ROV copy.
Alright, that's us at 16.
What's that? No, we're going forward. And then turn around. We only record on the line setting south. That's what I was doing. Okay. You find the ocean. Yeah, why don't we record all the way? Yes. Yes.
Basically to form from the seabed. You don't get your data. Get the instrument closer to the seabed. You need to get off back up there again.
Okay.
So I think you
Oh, okay. What happens after we're done with this is when we do the lasers and stuff. What is that?
Cool.
No, I think she went this far. She was saying lasers.
ROV size control, that's the CCD above 100 meters off the bottom.
Other copy.
Sorry.
Yeah, that sounds good there. You ready?
Yeah.
Okay.
Okay, starting.
Okay, recording.
Explain what's going on here.
Thanks.
No, I turned it off on deck. Oh, when you're coming out. Okay, that's 18. Oh, not the best one, yeah.
Okay, recording stop.
Almost the best one, yeah. Straighter, and I kept it at 10 for the most part. I got it down there now.
You have one more to do or two more to do?
One more.
19.
Is that not one? That other little bit? The short segment?
19 to 20?
The 19 to 20 is one more, and then 21 is to the northeast, midpoint between the runs we've been doing. So I don't know if we want to, I don't know what we want to do. So okay, they have, hey, wait, this is, we're going to go back up to here, and then right here.
Yeah, exactly.
And then right there.
Okay.
If you want to do east, let's go right here.
No, that's okay. That's another line segment. All right.
Gotcha.
Bridge science control, it's a CPD at 100 meters depth, and we're going to bring it in manually. Yeah, bridge copy.
Okay, so this is me set up on 19. I'll just get down to 10 on the sonar, on the Norbit.
You ready to go?
Just a sec here.
All right. What's the scaling there? 50. 25.
Laser, the laser, like real close. Oh yeah. Yeah. I was hoping it could look
Already copied.
go, but
Okay, you ready to start there?
Yeah, you all set?
Yeah, here we go.
Ready to start. Okay, recording is on.
Roger.
You're saying you can't get the data out to be able to get it.
I don't think I can get the navigation data. Is that Sprint? Do you know?
What?
The Sprint nav data. Is that only available at the end of the dive?
Well, there's multiple streams of this coming in.
I think the pretty raw stuff.
Yeah, so the raws we can get is the lodestar, which we can only get after the diameter. So we have to actually pull it from the lodestar itself.
Yeah, how about that bin file?
So we do also record the bin files on Sprint.
Okay.
We have had issues with the recording not being perfectly linear, so that when we do an import,
See how the red is touching the 10?
files.
Okay.
On the right side. I just go back to the side. Yeah.
Give it
But
a
what'll
try,
happen is
'cause I
if you
tried
go
with
up too
the
high,
dive,
it'll automatically
the bin
scale
file
to
from
50. Right, so now it's
previous
20,
cruise, and I was
but now I
getting
know
errors
now it's 10, right?
I tried to import it, so I didn't know if that's
Yeah, it's awkward. It's you
Yeah,
just
no,
kind of
it's
got to play with it a bit. But and then when you go to cliff, if the cliff is like this, it changes.
Sure, yeah. I mean, you need a right here on tonight. Yeah, you haven't had lunch. How about we can get lunch today?
Maybe I can comment on this one, that's fine.
Yeah, I can just finish the end of this.
Live? Okay, well then on to the coronary to the research part two. Oh, and then there's the raw.
So,
Yeah.
what I'm doing at the moment is trying to set up so our data archive for the whole cruise will actually just pull from these computers using Wikipedia. So it will actually start pulling all of them over to the primary archive, and then it gets distributed from there. But one of the options that it can do is to release the source as it comes once it's done writing.
Okay.
And it'll just pull it out. Now, with that being said, what I don't want to do is pull big log files first.
Yeah.
So I'm basically just going to pull any of the image or file and then pull them over as soon as it gets done. And we're doing this similar sort of thing with the video files. That seems to keep up.
Okay.
So I'm hoping that it's fast enough that at least the SSD still has.
Yeah. Those are from the patch test.
The problem is now is they can be all over the place, right? So
It's 108 gig. I just didn't want to delete them because I was scared of just throwing off the computer or anything.
Well, yeah, I mean, right now, if you look at the size of our website, that difference is see that we got like over half space freedom, so I don't think we need, but yeah.
Well, it's just those ones, I mean, those ones I know are not good. Once we start the next phase, like, if we can, I would keep them. If we can't, it's okay, I can get it. I can get it up, but
the thing is, they're getting this data too, right? So
yeah, so
I know I'm not in the 10 range, but
I won't worry about that. I'm just trying to where it was physically.
yeah.
Do not delete them?
Yeah, sure.
Okay. Gigabytes of black frame.
But I guess there's a black thing that's there.
Yeah, yeah. Have a break. There's going to be another 4 hours of this.
So yeah, that's fine.
All right.
Whenever we're on a plane, on a line, just like to take a line, as much notice as to make sure possible information. And then, yeah, what we're doing is we're starting the map survey, just selecting what actually is in the map. So the first one was the multibeam and the laser. Just using these mapping like the emissions surveys, cycle lengths, and then within transect sample. Yeah, and if you're basically selecting which gear it's actually on, so this one is and within that using the transect. Yeah, exactly. That's a couple. 20%.
That's the end there.
Thank you. I just
Yeah, this slope must have been coming up this way because this delta kept getting bigger.
Now we improvise. We need to keep the laser,
That makes
the
sense.
sonar on. Do you want me to?
Yeah, you're coming up.
Like
That's
this.
Yes.
This is, yeah, getting higher up this way.
That. Sorry? Yeah, when I print out one of those log
Yeah, you're definitely lower. See the differences up here.
Yeah.
About.
What was the delta? 65 minutes?
No, I want to get that to what it was.
all right, we can transit back down.
Oh, right, so yeah,
Waypoint 20. 25.
Yeah, one's right here. So.
We're on schedule here for again?
Yeah, we've, I mean, we started slow, but that was part of, I didn't realize that was probably going to happen, so yeah, we're doing great. I had like flying at 2 different altitudes with the laser scanner, but I think just based on the test, 4 meters are already too high.
Yeah.
So if we can fly more like 3 for the survey.
Okay, so are you wanting to go to 21 and then?
Yeah, we can go to 21, then we'll turn on the laser system,
Okay.
spend a few minutes just so, and then try to fly
21 to 22.
to 22. So like up the slope, very carefully, very slowly, back down the slope, up the slope. Because there's only about 2 meters of swath on this, so I couldn't draw lines because we only would see what's flying. So we'll just go back down, like shuffle over a little bit, go back up, shuffle over, go back up for the next 8 hours.
Awesome.
And hopefully it ends up being a beautiful reconstruction at the end.
Some of the ship here, give you 110 meters to 21. Now you get bring it back to here. 23's here. 24 is whatever that we might be going to 24.
Should be alright.
Yeah,
should be alright.
Yeah, 24 is the only outlier. 24, 25. That's what he's telling me. That's else.
He said you thought that would be 6:45 this morning, like dressed and ready for this call.
What's happening?
Oh, riveting. Oh, just riveting. What do you want to do? We are doing laser now, but I'll show you. So Alex put this overlay up, like a screenshot, or sorry, a picture.
This?
Yeah. So that is the sonar down there.
Okay.
So you can see the swath on both sides, right?
Okay.
So when they want, I think we're going to be doing laser for the next 8 hours. But when we do this is a good way to test. You see, I think it's paused right now, but you see how the red is kind of on the 10-meter mark there?
Yeah.
So that's how I was gauging altimeter for the laser to the bottom, if that makes sense.
Yeah. So basically, we need this to be on to gauge our.
Yes. But what'll happen is that as you come up a cliff or go down, it'll auto range. So all of a sudden it'll be 10 meters, and then all of a sudden it'll be 50, and you'll just see the little ticks. So you got to keep an eye on it.
I got a question though. Let me ask Kat though. So I saw in that dive plan. I thought it said when we did lasers we had 4 meters up front.
Yeah, but this morning with the tests, 4 meters, we're not quite getting enough back. We're undersaturated, but as soon as we hit 3.5, it starts looking better.
Oh, they're saying we're just lasers right now.
Yeah.
We are.
Yeah.
But
Oh, not right now. So once we get to the
we're
waistline.
transiting, but our activity.
So we're gonna go low.
Yeah. We're gonna be. It's pretty much like what you would do for a camera.
Yeah, because I saw in the manual it said something about like if you can see it with the cameras and the laser to see it, but
Yeah.
if you can't, you probably do far
Yeah. And that's the same for turbidity as well.
Okay. Oh, so you're just moving.
Yeah, I'm just going to 21 here, so.
Because we're always going up the hill, because as soon as we try to go down the hill,
it doesn't really show in the hill to me, but this is kind of like a big slope, but it's kind of like this angle, so you'd be going up this way, if that makes sense.
It's just going to look really slow out of consideration for the wire.
Yeah, you jump in there and get a feel for it, and then so the same with the lasers is if you can turn on the sonar, you can actually use the sonar to gauge the lasers as well, because obviously.
I think we got altimeter too now, so that's nice.
Yeah, I've been on the flats. I was using the altimeter, and then I just turned everything off and fly everything manually. I tried to do point to point on these flats, but I couldn't get the speed down down enough, so I just flew manually.
Yeah, and then auto depth and auto altitude, no, I figured that.
Not on the cliffs.
Yeah, it's just not. They're too.
They're all over the place. The best is just to give yourself a little bit of positive buoyancy and just like ease off. You know what I mean?
Hey, I was going to show you something too, which maybe this is normal, but I only just noticed it the other day, which is if you go here.
Yeah.
It's saying the transformer.
Yep.
But that's not updated.
Yeah, that looks
I don't know if
bad.
that normal updates, but that's said that when we were on deck and we just turned on instruments after it'd been sitting there for like hours.
Huh.
So I don't know if that's supposed to be
It might be a dead sensor.
reading, but it's not.
Didn't look like it's moving, eh?
Okay.
All right. Just you got auto depth on it though too.
Auto depth. Okay.
Alright, just off that knock down the.
If you're lucky enough to change the frame rate, you can cancel out the lasers on this. I did it accidentally, but I couldn't get it to do it again. So. Right on.
Thank you.
All right, Kat. So you're happy for me to come lower now?
Yep.
Okay.
A little more wire as it only gets it all.
Yeah, you can give me a little more. Hey, can you zoom out 1 or 2 text on your map too, just so I can see how the boat is real quick? Okay, yeah, that's no problem. All right, cool. You put it back if you want to, or leave it, whichever.
As long as you got a good view, come into.
first time we've gone together, isn't it?
I thought we did the other day. Maybe not though. Maybe that was a dream.
It's a beautiful dream.
Alright, so I'm about 3.5 off bottom here. What kind of hitting would you like me to have?
Towards waypoint 22.
Waypoint 22, okay. Roger that.
Sorry?
ROV side control. That's more than 100 meters off the bottom.
Okay, yeah.
I was wondering.
No, sorry, because of just until we get the line.
So you're still continuing as well.
Yeah.
We're going to go very close to the sea.
Well, around, I think. In the same direction. Well, it's just because it's going to be with
22 is due west.
Yeah, because we're kind of going around that feature. Okay.
Alright, just let me know whenever you guys are happy and we'll cruise on.
So say new event, laser survey. We're gonna, it's gonna be, yeah, we're both, so I will put it here. Yeah.
The autofocus backwards or something. Seems like it's still.
It might be. You're going to focus on sea beds?
Yeah, just kind of far out kind of look, you know?
Yeah.
Oh, you know what? Sorry, I'm looking at the wrong camera.
Oh, you're trying to get stick now?
Yeah, I can do that here. Boop. Got it.
They do have an offset of the line.
No, I think
Where's
the
the slope?
No, the seabed is just over there.
So I can't focus on the head too. Listen with that.
Should I bring behind the swap for the multibeam or?
This type of stuff that you cruise?
No, I'm just. Yeah, at least first. I'm
So we have it at
personally
160.
a big fan of.
Bridge, that's the CTD at 100 meters, and we're coming manually.
Of manual flying
Yeah.
without a lot of autos because it just tells you a lot more as a pilot. Like if you're flying forward, for example, and you start doing this, right? That might mean that you lost a thruster or you're hung on something.
Gotcha.
But you would never ever know if you had auto heading, right? It's gonna just do that, take that away for you and fight it. And there also a lot of autos aren't smart enough to know how much to fight. So like say you were working near a rock or a structure,
Yeah.
and you bumped against it and you had auto position or whatever, and that shifted just a little bit and it thinks you're supposed to be in the rock, it's going to drive that sub into that rock so hard it'll break something. Does that make sense?
Yeah, absolutely.
So autos definitely have their place, but in my opinion, it's sort of like, I'd really like to at least encounter a situation a couple of times with manual first and then use them as I need them, you know?
Yeah. Okay.
Now this it does have some pretty advanced stuff it can do, like with this auto track and things where you can even put all this in. And I might consider doing that if it was pretty flat ground, you know, because then you could do auto altitude and you could even tell it to run these lines at a certain speed and it would probably be able to do it pretty good. But seeing as how it's boulders and this is all experimental and auto altitude is notorious for being terrible around boulders and uneven ground, it's like, this way I just feel like we're most likely to get them the results they want, you know?
Bar, the pressure.
When we were doing some like higher altitude, like 40 meter swimming last time, and people would use the like station that's like you just go through water column, right?
Well, then it's actually probably better than flying because you have no visual reference. But at least here I can see. Oh man, I forgot my mask.
And you're coughing.
Yeah, should I go get it?
I got you.
Yeah, it's on my desk.
You want a fresh one?
Sure. Thank you. What a noob.
All right, when you're ready.
I'm
Good?
happy.
You're flying?
All right.
Okay.
So go for it?
Yep.
All right, I'm just going to move ahead and I'm going to maintain about a between 3 and 4 altitude and
like, cause yeah, we want green. So green is good, blue is too far. And
where are you seeing
laser?
Green? Oh, right there.
Yeah.
That
And then you
okay.
can see the distance with the first return of the
Okay. And
the
just
laser.
a nice consistent slow speed up to waypoint 22. That's what you're
Yeah. And then we come back down to the bottom, pretty much exactly the same spot, a little over.
Okay, let's go for it. Moving ahead. You can Roger Jimbo if you want to.
Maybe that Jimbo.
It doesn't feel too lonely. Like nobody cares about a CTD.
We do care.
People do. That's all I think about, really.
Yeah, I did that last night.
Is red bad?
Red is too much, yeah.
All right, so
I might have to adjust it, so let's see, because we haven't managed to be that close, so.
All right, backing up a little bit.
I mean, if it's easier for you to fly closer, I can also change the exposure time to something less. Yeah, good. We're now slowly lasering up and down the cliff face. Dan, what do you want to do for the next dive? Do you
I'm
have?
actually just going to talk with James because we're going to come up with a plan.
Okay.
So do you have a? Do you think you're going to be doing this all night?
I'd say for the next 8 to 10 hours, maybe the laser, and then we have a little DBL survey.
See, that's actually more
Yeah, coming
useful
back
than
in the
altitude.
wee hours of the morning.
Because my altitude's
Then
not
maybe
jumping
doing-
crap now because there's a
if we're
cliff under me. You know what I
doing
mean?
a line around the multibeam around the Cacho while they turn around the vehicle, but should only
Fish
take
better
about
get lazy.
2 hours.
Close your eyes, fish. Go back to it's coming for you.
Exactly. Yeah, so when they turn around that. So either what we've discussed, either
It'd be
sort
funny
of
if they were
along
like a
those
cat and they
cliffs
just started
along
like
the-
jumping.
Yeah, this one's done.
the original Alvin dive, or checking out the bottom at the same depth.
This is a
That's the
really
Alvin dive.
steep thing
On the
here,
other side, on the
so
other point. Yeah, so
you're
those are
not
the two
into
guys
this?
I'd like to do next.
Yeah.
If you're happy to plan that.
Yeah.
Okay, awesome.
I'll get that good.
Oh, this is exactly what I want to be imaging. Awesome, okay. And yeah, you got dive plans on the, yeah, if you want to follow the same style or not.
oh no. What happened to my laser?
Just yeah, I think we're a little far.
A little far? Alright, I see a little red mixed in there.
a little close.
Yeah.
Yeah,
It's gonna be tricky because there's a lot of structure, so.
yeah, I got like the whole rainbow up there. Red, green, blue. Alright, moving a little closer. Nice and easy.
Now I can't see it.
Uh-oh, went away. There it is. How you liking that? That's a little better?
Get much of that height.
I gotta say that strobe is very Halloween-y. Subsea haunted house here.
With I just bought a bunch of black light for my Halloween decoration this year. Kind of
Did you?
looks like that
Nice.
laser.
It's a very bluish purplish laser, isn't it? Interesting.
And then we come back down, we gotta have a 33% overlap.
What are these perfectly round?
Sponges?
Those are sponges?
Yeah.
Alright, backing up a little bit, I see a lot of red.
Yeah. Perfect. The exact kind of flying we need, I think. For 8 more hours.
Slow and steady, huh?
Yeah?
We want to make the full coverage places.
Trying. Yeah.
So you do it in one direction, that's what you do?
Yeah, up to the well, but it's gonna be more like around. So I'm hoping we definitely get the top and the bottom. Let's see if we can. But the top was like neat, so.
They're kind of like in those movies, you know. The alien invaders always have some kind of a scanner like this where they're looking for the lone survivors, you know.
Yeah.
We've got a bit of an overhang here, it looks like, so this might be kind of interesting to go over this. Like the one with Ripley?
Yeah.
Oh, yeah. Yeah, they're pretty good. They got a little weird near the end, though. The first ones were, of course, those are classic.
College is my favorite.
Yep.
It's a long time, actually.
Is it?
Yeah.
You know, I need to watch that again, man. It's been a long time.
It's got like yeah. I watched a bunch and it never gets old. It's got this really unique screenplay.
This guy actually sticks out from the wall a lot here.
Yeah.
So it is going to be interesting to see how he does.
I think as we're gonna pass over and over, like sometimes we'll get the good stuff in the back and sometimes we'll get the good stuff at the front. So like we can't get everything in the perfect scan, but that's okay because we'll do multiple scans. Hopefully doing scans from slightly different angles so we get into those crevices.
Alright, starting to move a little closer again now. I'm out from the overhang.
So pretty much that's the feature we're trying to map, sort of
This
all
one?
the way around. There's going to be a part we can't map because I think it's merging into the larger ridge.
It'd be pretty hard to get the bottom, I think. I'll try anything once.
Might be a little on the high side now.
Coming down all the time. Nice and easy.
I think that, sorry? No, we're going to come down. I think this big lump is going to be our top. So we're going to keep going back to this lump.
Alright.
And then back down.
I like the lump.
That'll give us a, that sea urchin is going to be imaged very well from every angle if he doesn't move.
Maybe he'll be a good like reference, you know?
Alright, I think we can go back down to 21.
Back to 21.
Yeah.
Like, am I scanning back or am I just flying back?
Just flying back. So I guess I will stop recording.
Alright, backing up then. I turn to the left, so I'm going to turn to the right.
Pause the laser.
Yeah.
Same event, no, it's just lost. Yes, yes.
Yeah.
Good for a break.
Something in my left there.
All right. Thanks, Rich, for filling in there for a bit. Let me go grab a break and my lunch.
Roger that, Jimbo.
So CTD's still going. We've seen it come up to the surface at least once. I think just the one time. So we're doing basically a yo-yo deployment of the CTD. It's just going to go up and down for like 12 hours.
Yeah, but at some point, yeah. The thing is, you have pictures, right?
Flying smooth.
That's true, we could get the picture of the bottom of the...
At least the sub is.
How about the hands that are manipulating those paddles?
The good thing is that there's lots of
Pilot could probably do better.
Umbilical's good for you? Not yanking on it?
It was really good, actually.
Yeah, because it's flying to get back. That's 180 degrees turn.
Yeah. Oh.
That's from the stroke.
Yeah.
Okay, I'm back kind of at the 21 point here.
Oh, it is. Yeah. Okay, we're back on 21.
Yep.
Okay, so now we want to pretty much follow the same line, but half meter to the south.
Half meter to the south eye.
We good?
I'm good.
Start of line 2.
Keep a big zoom on my screen, see if that's useful for you there. To that side?
I think we were slightly.
Can you guys put that laser screen up there as well?
Oops, sorry. Yeah.
That was pretty useful.
That was useful.
Thank you.
Green.
We like green, right?
Yep.
Green's our friend.
Did we decide green is good?
Green is good. Green is good.
I remember there being a debate, so.
It was blue. Yeah, blue. What is blue?
What is red?
Red is over exposed. Blue is under. Oversaturated.
A little bit sooner.
No farther?
Darker here, yeah, I think it's the same line up there.
Well, they want me to be a little to the south, remember?
Yeah, that's like happening here.
Okay, everyone remember those 2 anemones. Did you go revisit the 2 anemones?
How's this speed? Yep. Is this speed okay? Or?
Okay, that's great.
Okay.
Very familiar with each individual pole as well.
Yeah, I didn't even see that.
No. It's on the way back we shut. Yeah.
Keep an eye on the red on this one.
You guys can catch that spot lobster.
Let's see that. This is an old
Yeah, there's nipples in it. So you can catch the spot lobster.
Yeah. They're ready to fight.
You can't.
ROV science control, that's the CTD now, those 100 meters off the bottom.
Roger that, Jimbo.
CTD is currently 100 off bottom. Is that what it is? Okay.
Probably like 8 to 10. Since I had it because I
Do you
wanted
mind
to try
zooming
different
in
altitude, but we
one
already
check
know
on
that's where
the map on my screen?
So you're getting close, but you step.
Yeah, so I think this is like
That's it.
safe for them to fly. They can reliably fly it. The data looks good. So I think we'll just do a thorough one like that. And then I'd love to do like a real close up.
What's that?
One of those coral.
Just keep
Maybe
me
at the
honest.
top, we can really fly all the way around.
Just with the ROV. Just with the ROV.
Let's narrow that down.
Not live.
Manageable amount.
Let's see. Toss another one out there.
Here's this overhang again.
Should really catch it under the stuff.
This readout we're seeing is flipped, huh?
Yeah. Yeah.
Okay.
Line.
Back to 21.
Back to 21. Right next to those two anemones.
You look pretty good, man. Pretty good.
I wonder if it wouldn't help to if we could get the overlay of the Norbit
Oh, we
or
get,
the laser. So
they do. They give us a little laser thing, and
because he said blue is bad, green is good, red is meh.
yeah.
Red, yeah, is
Wash up.
when it's too close, like you're getting too much back.
So she's
Blue,
been
you're not quite getting it out.
she's been giving us that. It's super useful.
Cool.
Although there are parts where you're going to get blue, green, and red all in the same one, just because
of the makeup of the
doing that kind of thing.
The
But
complexity, but it's okay because we're gonna image some other part of the cliff on a different line, and then we might get that one in a green spot.
Cool.
is there a way to make your snail trails more persistent?
Like, you want me to clear it and start it again?
No, but like I wonder if they're going to go away. It's good enough now, but like if we're doing longer lines, it's really useful to see where you work. Because you can just stay just to the south of that.
Yeah, there's a buffer. So many hits and then it disappears.
You can't really alter that.
Not intuitively, no. I'd have to maybe in the YAML file somewhere, but
Well, it's great for now. It's just if we did super long lines, it might be a little harder, you know.
Yeah.
Go a bit out of time.
Yeah, so, yeah, because you can follow your line back, right?
Yeah.
Yeah. Yeah, it took me a line or two to get mine dialed in. You can see 22 to 16 was bad, but then 18 was good.
Okay, I think I'm okay here. If you guys wanna.
All right, start with line 3.
Is that a glove? You guys see that? Just to the left of the Norbit on my sit cam? It's a glove. Huh. Alright.
Never get away from trash. Oh yes.
Okay.
Sorry, line, yeah.
Alright, so you're happy to move?
Are we all set? Are we back on to...
We can't quite.
Oh yeah, we all set.
Hard to decide.
Okay to move here, Dr. Robert?
Yep.
Okay, moving in.
For anyone who might just be joining us, this is live footage from the remotely operated vehicle SuBastian, being piloted from onboard research vessel Falcor 2. This is dive 578 of SuBastian and our second dive of the vertical reefs of the Galapagos expedition. This footage is coming to you live, so our pilots are slowly navigating SuBastian up over the terrain, and you can see the blue laser line down at the very, very bottom of your screen. And as that's going over the terrain, the sort of perturbations in that line are being measured, and it's just scanning its way along the bottom.
The question is still there.
See, that is good.
Okay. Zach says he's not using the science camera to fly at all, so Tyler's just going to have a little look-see around, but we won't be able to stop and really look at things too much.
You might as well see what's there, though, you know?
Yeah.
Taking out the time,
okay.
But you'll have all the locations, so you can do a 3D reconstruction of this entire area is what we're hoping for, but then we won't know the time unless we then can overlay the track of the ROV on certain models.
Okay, yeah.
And then you could possibly fly the ROV doing what we just did. We've done something like that before.
That's cool. I mean, there's lots of these little squatties now just like standing like this, and they're staying still as we go past, so you might get them.
Hope so. And all these corals is all
I know,
stuff
I know.
I'm hoping.
Yeah.
And the spot lobsters.
That's true, that's
I think
true.
we might be able, I've seen a crab in
They're very cute.
the laser scanner data once.
I'm excited to see what level of detail we can get on the corals.
Me too.
That's going to be real cool.
And at the end, so now we're still flying a few meters away, because obviously this is really rough terrain for the ROV. We would want to be hitting any of the instruments of the ROV.
Right.
But once we're done this part of the survey, we'll try and find a nice exposed corals that we can get a little closer to, and then get that in really, really the highest resolution possible we can. Lost at the top now. I don't see our little knob. Are we over there?
You know, a lot of these like squat lobsters and stuff are actually like posing.
Yeah, they're just hanging out there.
They don't want to be a part of this.
Yeah.
We can do that.
Yeah.
Here we go.
Once the 60's done, That's actually going faster than I thought. We're actually, I feel like we're.
How's it going?
Good.
So I just chatted with James a bit, and I'm now trying to find Stuart to talk to him about his ideas
For the next dive. So, wall or other side of the horn?
What's that?
Wall or other side of the
I think one of the things that James and I were talking about was going on the extension of the wall that would go out and move it up higher, but along that wall image with the 710, so that you have opportunities to sample or to be able to map some of those walls too, which was down. But it will also give us a chance to get from below
shallow to go.
Yeah, below to above the oxygen minimum, right?
Yeah.
In that area. That's one thing. And then maybe the third sample guide, if we have a third sample guide, would be on the other side. There's a very curious feature down on the southeastern horn. That is, I think, maybe current scale, but it's basically making a 50 degree slope in sediment.
You're happy to shall I send somebody in call from Norbit? Or yeah, if there's someone who's available, if they're not on shift yet. Everyone's on shift all day today. Yeah. Yeah, I'll send somebody in.
So anyway, so at some point I want to chat to you about that too.
Well, I'll be back to planning for the third one. So, do you have a track? An RV track? Not yet.
No, not yet. I wanted to chat with Stuart first, and then also to make sure that I think we're representing or we're considering what the land sensitivity to in terms of Carl's and whatnot. That's why I want to put Stuart's on that.
Perfect. Yeah, and then I mean maybe Ollie might be interested in doing that spot. That might be a dive that's really exciting stuff.
Where for the second one?
For the second one. That next step.
No, because we'll be moving around a bit. So, yeah, I don't know. Do you need me to sit here for a bit? Or?
I don't think so.
You all right?
Yep.
Cool.
Hey, Dr. Robert, how much further south are we going to go?
I feel like we're gonna encounter a wall real soon.
Yeah, that's what I'm looking at. I see. We got a couple.
Start seeing it?
Yeah, we got a couple of more, but I see a cliff to my left. So
yeah. So
before too long, we're going to run out.
When
of
you
room
feel
there.
uncomfortable with that cliff on the left, we will be going the other way.
Okay. All right. So I think I'm pretty happy to do another one if you guys are ready.
Started line.
ROV science control, that's the CTV within 100 meters of the sea level.
Roger that, Jimbo.
Super. There's your two anemones. Now they're just outside.
I thought you were working with that one. Planning the next dive?
You know, just have a chat. I'm just going to talk to Stuart. Okay. We're going to ask you about
Pretty nice screensaver you got going over there, Tyler.
No, you're mesmerizing me.
Which way is it looking? Just to the left a little bit?
Yeah. Yes.
There's some little fish in there. Rockfish.
You can't look at it or I'm going to crash though.
It's not scary.
What's that?
As it's got into it, they go really interesting. It's not that far down too.
I think I'm coming along with the cliff.
But you can see the laser line there.
Yes, yeah.
So we're very slowly scanning from the bottom to the top. Back down, backward down.
Yeah.
So we started up with 0.1. Wow. I think we're hitting that. We're getting close to that left side cliff.
Yeah, that's why I'm just going real slow because it's getting a little tight. It's an overhang, you know?
Yeah, this is exactly what we've been wanting to map.
Is it?
Yeah. It's super complex.
Zach's like, we have different dreams.
So I like a good challenge. But you know what they say, no pain, no pain.
For the laser scanner, blue is a little too far, green's good, red's a little too close, it gets a little tricky when you got corals coming out.
Yeah.
Corals are.
I know y'all like the coral, so I'm trying to put those right in the best.
Yes, that's right.
In the best spot.
Getting out of the laser, is it?
So there's an imagery camera, so there's like super fast cameras that we can do structure from motion construction on. The list scanner is a bit like that, really high resolution.
Yeah.
Instead of using sound, it uses lights.
Yeah.
So you can get like very high.
I know what you mean. Yeah.
Distance to the camera, that is very quite fast.
What is your ideal distance when it's green? What is that?
When it's green, so that's around like 3.5 meters away.
Right.
Because we also have the multibeam on top, so what you're seeing there is like the top of the laser, and on top is the multibeam. So it's 3.5 to the multibeam, which is what the lasers are over. So.
Yeah. Cool. Yeah, I've been enjoying it. Kind of flashing lights and lasers.
Yeah, that's great.
Yeah.
It's a good one.
When we can.
It's nice to have something to water.
3 or 4 hours. Or
Yeah. Oh yeah, over there it makes it big for y'all.
Sweating a little bit, but
Got it. Got it going.
got it working.
Nice.
It was always working. It was just logging the data on the sensor so we can see it. We kind of knew it was happening, but we kind of wanted to see the data. You know, like, I'm not doing 12 hours of data collection.
So I
and
just-
see that we're even getting that.
That's the end of
That's
that.
why.
But I see it looked like it kind of locked up right there at the end.
Yeah.
All right, going back to 21.
Are you comfortable doing one more on that side, or do you want to move north?
No, I can do another one.
One more?
Just worst case, we might have to kind of like,
Yeah, we can
Come
always
up.
cover the same ground that we've already covered.
either that or we'd have to come up where some stuff's kind of out of range, you know?
Yeah.
There's a cliff.
I mean, if we get a little bit more on the bottom, I feel like the bottom, that cliff wasn't quite there, and then the cliff. And if we don't go all the way to the top, that's still. It just will be nice to try and get an actual full feature.
Swing side camera with two, so yeah, put a set of eyes on that. Watch someone go see. Watch someone go see.
Nope, no one was sitting there. But if you want to finish like with Dan and then come back in like 30 minutes or so.
Yeah, sure.
Yeah. And then are you still good for 30 minutes? Yeah.
Great. Alright, okay, so we're finish up.
Yeah. And then I'll come and see what the GIS track looks like. Are we doing it in the GIS or just like
I think we also, we just discussed it yesterday, so.
Okay, alright, great.
I'll tell you the rest of you.
Okay, awesome.
Cool. Thank you.
It's a good setup here too, where we're just going up this little hill kind of thing.
Sorry?
So it's a good setup here too, where we're just going up this little hill over and over again. Like,
Yeah, I'm starting to know it very well.
well, it'd be a lot harder if it was like, we'd still do it, but you know what I mean?
Up and down, yeah, I know.
This is just a pretty nice overall.
Uphill, all the way around. And, yeah. Well, especially, yeah.
Because the problem if it has a sudden big drop is then you can't drop down because you'll hit the sub.
No,
So
I
you
know.
gotta wait.
The laser and the multibeam are looking forward.
Right. So you get sort of a
You
gap.
would catch it.
So yeah, this spot's perfect. Oh, dokey, there's Mr. Glove. going to go a little bit to the left of him. And
Please start control at 60 CTD at 100 meters, and we'll bring it up on the manual.
Roger that. Thanks, Jimbo.
Yeah, copy that.
All right, I'm ready when y'all ready.
Alright, start them live.
Do you mind putting that waterfall?
Oh, sorry.
So I can get the arm pivoted out too.
What's that?
The arms pivoted out a little bit too.
Yeah, I think we did that earlier because we wanted to make sure it wasn't in the multi-beam, but you can probably move that. If you're worried it's going to hit anything, for sure you can move it.
Temperature's up since we started.
Temperature's up?
Just since we started, like the temperature that's being reported.
Well, water temp?
Yeah, water temp.
So with this kind of
Yeah, little rockfish, I think.
this kind of stuff, Tyler, actually been like right around here. I'll start backing up a little. You know what I mean? Because I know that cliff's going to come towards me.
They're bright though.
As I go up here.
Yeah, copy that as well.
Just trying to follow that overnight.
Yeah, just because I don't want those corals to suddenly be in the red zone where they can't get anything, you know?
Yeah.
Anything past 10 meters we lose because we have to put the range filter in.
It's a little bit light today, so.
Yeah, it is. It is.
Okay.
We could probably put another thing on it, you know?
So when you're coming up, it's not the first one, it's like rotation for you.
No, I'm using verts, but I have it artificially neutral right now. So that's a really good trick to know. Actually, it's better in my opinion than auto altitude or auto depth.
Okay.
Is when you, like, say you're sinking.
Yeah.
You just put on up trims until the point when you stop sinking, basically, or vice versa if you're light.
Oh, I got you.
And that way, like, if you're flying in auto depth and you suddenly stop going up, it will lock and it will go trying to hunt and find that depth that you stopped at.
Yeah.
And that can be kind of annoying or bad in situations. And if you're doing auto altitude, of course, it'll follow these boulders and go crazy.
Yeah.
But if you're just trimmed out to where you're artificially neutral, it doesn't do either of those things.
Well, that's awesome.
So it works pretty good. The only thing you gotta watch is if you're not paying attention, you get too close to the bottom and you're thrusting down too much. You can blow stuff out, you know, blow fish out.
Gotcha. That's handy. I haven't done that before.
All right, watch my left side here for me if you can.
Yeah.
This is where it was close. I got to stay a little back here.
Yeah.
Unless you want to do an accidental sample. Surprise sampling.
You're looking okay on the full side anyway.
My scans are not going to match if you bring pieces off and
Yeah.
Oh, that's a good point. Yeah. Okay. Let's not do that then. I think we still got you good stuff there, hopefully.
I don't think so. One half is good. Once you get into that deep edge.
Hey, Tyler.
Yeah. Could I have you drop our shutter speed down? Just see what it was.
Yeah.
Looking for effects of the light stroke. Just see it. Yeah. Just see what happens. You might get a little glare.
Yeah, it'll get brighter.
Oh, yeah. Yeah.
How many lines is this we've done? 4?
Alright. Oh,
Is the 5th?
no, it's not going to go. They got it at 60, but it was like, I think it just happened to be turned on right at the right time, and it was in between. It was so perfect.
Alright, end of line.
It's just magical.
Like going back to 21?
Back down to 21. I don't think we can really go more left, right?
I mean, I'll certainly give her a whirl, you know?
But if anything, I think maybe we can do one more line in between the two.
Oh, the one I just did and the one next to it?
Yeah, I think
that's
there's
fine.
a little bit of a greater gap there.
Sure.
I can recognize individual corals.
Sure. Nay bother.
Nay bother.
Nay bother.
It's like white grass.
Yeah, I'll have to bring one of the mics from over there and load it over in this
Oh,
corner.
here, huh?
Yeah. So you were thinking y'all were going to be like logging over there? Because that's just where everyone seems to log behind
Yeah,
that science lead.
Look at us, and we just set up all the way in the wrong
That's alright.
other spots.
I'll just bring a microphone over and get it out of the pilot's face.
Leaving us behind.
So how many dives have you narrated?
This will be my 3rd cruise now. Yeah. And then I was on Nautilus briefly in 2018 as a fellow.
Okay.
So I did a little there. Their setup's a bit different. And then, I mean, I've watched live streams for like 10 years at this point. Yeah.
We can see it really nicely on the photographs, actually, the tracks.
I know, yeah.
So
Yeah.
we are,
Let me put that up.
we're getting in one of those valleys in between.
Yeah, let's see. Yeah, you can kind of see like how it curves. And if you bring it down, you can kind of see how high off we are, although it's all exaggerated or whatever.
But we're trying to map this this feature here. You can't quite see the detail of it in this resolution, but there is something here.
And do you know what resolution this map's at?
Okay.
50 meters, I believe. This one. No, we've put the. No, sorry. 5 meters. We put the brand new stuff in.
Oh, you can see the.
Yeah, so
Okay.
that's the cruise we took this expedition with the 712, so that's the shallower water multi.
Oh, this is our new one.
So this
Okay.
is our new stuff. What's underneath is what had been collected before, and that had been at 15-meter resolution. So now we're down to 5-meter resolution.
Okay, 15.
And with the laser scanner, we'll be going to millimeters. Yeah, so we're trying to image this entire feature. Yeah.
That'll be cool.
And so we hit some of the lines with the multi-beam, so we'll be getting out meters to 30 centimeters with the multi-beam, and then a few millimeters. But we gotta cover this entire feature at this this level.
I'm ready whenever you are.
Ready? When I stop talking? All right, start a line.
Sorry, I didn't mean to say it like that. I just. You guys, you want me to go?
So rude. How much does the because you flew it here? How much does the laser weigh? Like that big cylinder?
In the Pelican case that I carried it down with was 59 pounds.
Okay.
Yeah. But it's not that heavy, the actual laser.
No.
It's a lot less than a mass spec.
Yeah.
Another very useful reference for it.
But it is a little much to get off of a water taxi when there's waves. I can tell you.
Oh gosh, yeah. How did you guys do that?
It was exciting.
We made it work.
It was exciting. Do we normally zoom in on that thing, or is that how it always is? In that little waterfall.
I put one up for you a lot of times.
Yeah, I zoom in every time we stop and start. It goes back, so I usually zoom back. Yeah, that thing was way rougher than the day we came in.
Yeah, that was exciting.
Yeah, so it was 59 pounds because the pure later ticket was a lot.
But at least we knew it's subsea rated equipment, so if it went in the drink, we could get it back.
It's our little squatty friend on top of the coral.
Yeah,
Thing is like if they move in between scans, there's gonna be this
Yeah,
weird like crab with 20 arms.
ROV, CTD, 100 meters from the bottom.
How did that, Rich?
I feel like I did this line before, but my snail trail disagrees. Got deja vu on this one.
That's exactly what we want then. Because we know that we've covered it. Yeah. So the patch test, the multi-beam, the laser, yeah.
And the one that had like both them running, I would put like a preference one, like one with the full beam and the data was on.
Yeah.
And then we'll put it in the comments.
Yeah, we'll have to sit down and discuss that one. That one might be a little tricky.
That's a wrap.
Alright, back to 21 and we'll start flying the other way.
You're doing the same thing but to the north, right?
Yeah, to the north, and then it'll slowly curve west. So yeah, we've done about a tenth of the feature, I think.
All right.
Yeah.
That's cool.
ROV CPD, 100 meters above the
Roger that, Rich.
There's some kind of zen about this, you know?
Mm-hmm. It's very meditative flying, isn't it?
It is.
So you're raking out of the sandbar.
That's it. When you got through when Max was over here, the RCC,
Yeah.
I hope that dude picks up you. He was a blast.
Yeah, he was a great presence on board.
I don't know if they would do anybody twice though.
Just installing him.
Just hire him.
Yeah.
Do we have an artist this time?
Oh, I think so. We did last time, did it? I went up there.
Okay, so I'm just gonna go a little teeny tiny bit north of this green line now, right? So I'm happy whenever you are.
Okay. Ready, start flying.
You know, I always did like road trips. That's what this kind of flying feels like. You know?
What's the furthest road trip you've ever taken?
Well, I'll tell you, when COVID broke off for a while there, I was driving to work from Cleveland to Louisiana.
Oh gosh.
Quite a few times a year. Like I would drive down to go to work, drive back up after, and so I got pretty used to that one. But we did all kinds of them. We did, when me and my wife got engaged, we drove all across the West to all the national parks.
Nice.
From Texas and did a big loop all the way up through Glacier and Washington State and all that, and that was cool.
Yeah.
Oh, there's our two anemones from earlier. Well done, we're right where we I started the scan.
Check out to Washington State, you know, last year. Is that where you're headed?
What's that?
Are you headed out to Washington?
Yeah, we did get out there. We got our RV out there.
Hey, how you doing?
Great.
Hey, so I just I talked with James and talked to Stuart. So we'll.
You got a plan? Should I come and see the plan?
If you have James is in it.
Do you think you can move to this position? And James will move to this position? So
I just need to stop the start.
start, stop. This one stops the recording when it stops recording, but it still plays the data. This one stops playing the data, and then you might have to zoom back in and out to get it to good. Right.
So already with the starter, or both of them starting, the stopper have to stop it and stop.
Yeah, that's it. And I usually do it at the top when I see the laser line is going in the distance over the side of the cliff, and then stop line, and then come back down, and then we slowly go north as we move over that feature. You can really see it on the later maps.
Yeah.
You gotta go all
So are you going up and down or side to side?
up and down.
Going up and down.
Yeah. With the laser, you gotta cross the laser for the line.
What are you doing here?
So here, this is for any, so the splitting cover, and we can do with it. Now we are doing line standard, so we pass it back to 1.1, blah blah blah, line 8. Here, right now we just have to do marking traffic.
Okay.
And add the line. So it's gonna be marking traffic, and add the number, and start the end of the line. So now that we start recording, marking traffic, and the timer, and the number, it's gonna be 7.
So we're doing line 7 now. Yeah. And then the start of the next one will be
8.
line 8. Right. And then you want me to make notes in here? Like,
Yeah.
So at the end of line 7.
Basically the same, like normally it could be artificial, you can already see the log. If you go to when I put the line 7, the starter,
Right, yeah.
you can see the altitude. And just take the the 7.
That's right. Right.
Like, because she was talking, maybe I just did it, but not that it doesn't have.
So, translate.
Yeah. But one, and that's it. Later is gonna be this one, but I'm not. I don't know what it is.
Okay.
Alright. So stop.
Heading back.
Yes.
So that's the end of that.
So Tyler, I've been
So yes.
also, you don't have to, but I've been kind of like moving more towards the middle of this bundle and then moving back with the idea that then I can use that northmost line as my reference, like where I need, I've already done it, you know?
Yeah.
Because the first time I kind of I went all over and then I kind of messed it up.
Gotcha. You see your last line clear.
Right.
Like that.
Oh, Norbit.
It may just be.
Once they got some more nice overhangs on that. It's kind of fun, man.
It's not bad. It's not bad.
Sometimes I mean, if you don't believe it over me, it's just that stay.
It's more fun on the 40 meters up, can't see anything, just go to the next station.
Yeah, awesome. I can look as a user, as a different user.
I think it was a good thing we did the 2-hour rotations, 8 hours straight is your brain would be fried.
Yeah.
It's a lot of laser flashes too.
Okay, I know that end design.
I think with on a small circle, you're kind of immune to sounds and lights.
You're gonna see these flashes in your sleep.
It's just not fun.
I'm fine.
You'll see them behind your eyelids.
It's a lot more than that to annoy me.
the comment.
The oldest is 12, and the youngest is going to be 4 tomorrow. It's his birthday.
Can you guys, do you still hear the sonar when we're mapping?
It's not showing up here.
No, don't worry. But
Oh, the big one?
Yeah, like yesterday, did you hear it? The 12 hertz?
No, I wasn't paying attention. I can't hear it, but I can tune out.
Yeah. No, I was sitting in computer lab and I could hear it going. Some of them I can hear, some of them I can't. Jimbo can't hear 12 hertz anymore.
Yeah.
Yeah.
So we go back to waypoint 21?
Yeah, we. Yeah. Yeah, we talk about it. You know, it's like some of the sonars, some folks can still hear them quite clearly, some folks can't. It just is what it is. But it's always interesting to pull up, you know, there's like files you can pull up that just work their way through all the frequencies. And if you're missing something, it's odd that it just suddenly stops making noise and then it comes back. Yeah.
Okay. I think I'm ready for another line here, if you all are.
All right, then let's start the line.
Okay.
And we're back. You did it?
Yeah. We're still between waypoint
Bridge,
21 and 22, right?
Yeah, a little bit.
So you can see,
Yeah. Good last one.
keep going what you want to do.
Just seem to want to go
Yeah.
a little more to the left for some reason.
Stop those?
Yes, I have to continuously kind of correct for that for some.
Go down, guys.
One each.
No. Oh yeah, that's probably it. The local pole in there, right? But yeah, I think I'm okay. Hey, you know what? Go ahead. Give me 65.
North.
It's free, right?
What's up?
It's free.
Yeah. Maybe 66.
I still got to drop home.
Yeah, that's true. You gotta be responsible. Huh.
We got crab hanging out in that little crab shack.
Oh, yeah.
Hope he's got it made.
Living life.
Got his anemone there.
Use a great deal of lake there.
The laser. Yeah, some of those fish are definitely going to get good scans.
Yeah.
They're just sitting there.
There was one earlier that like swam along with me as I was scanning, so I think he's going to become like 14 feet long.
He's going to be like one big smear. Yeah. What a jerk.
You know where we end up so far. We've been wondering where we'd be, you know, watching bees.
That's a fun little star there. Yeah.
It's nice to start for a while.
Yeah. Yeah, I see.
there is, so we did this one.
There's a big coral.
Oh, yeah, I see.
Yeah.
Yeah, and then we did it with the
Yeah.
Yeah, I mean, the laser was on, but we did it with
You're gonna get him.
These are all white, aren't they?
You're gonna get zapped.
Still get a laser to there.
Hope you're ready.
Yeah. See. Where's the laser?
when we zoom in now, we're doing this time.
Yeah.
Laser, because those are multibeam is on.
Yeah. Is that fold down all that? And this is multibeam.
What's that?
Sticking out the top of the cloud.
Yeah, yeah.
Yes.
Yeah.
I think it did.
Awesome.
Bridge 60, 100 meters below surface. Well, yeah.
Is this are the captured images? Is that today, or is that like a portion of today's dive, or is the whole thing?
What, sorry?
Where it says like captured images. Is that all the ones we've caught today? Okay.
It's not that bad.
So
Yeah, so far it's fine.
yeah.
It's more tricky trying to figure out how to get around stuff when you're and still scan it and not run into it, because some of these rocks are like sticking out towards you, you know,
Yeah.
and like you got to go up and over them,
Yeah.
and then you got to get the stuff behind them and down there, and so that's kind of interesting.
Tricky.
End of line?
Yeah.
Get the multibeam being like, that doesn't look right, right?
Yeah, the sea log on this is odd. So my startup line hasn't come up. It has on mine.
Okay.
We have two startup line sediments that haven't come up. So
Okay.
we haven't started it. I've commented out the incorrect one. Yeah, that was my mistake.
These are mostly useful, and you can look at the file start and like
Exactly.
go around,
Yeah,
so you
yeah,
know it's
sure.
that file. useful for it to be stretched out
Yeah.
earlier, but now there's nothing.
We need to get you a second monitor.
What?
I said we need to get you a second monitor.
Oh, yes. Yes, there isn't enough monitors in this room. Please add more.
It's the first thing I thought.
Yes, yeah. Some on the ceilings.
Well, and so all of these up here can be quadded. So all of them can have 4 screens on them, and all these can have 2.
So we're operating at like a third of our available capacity right now.
Yeah, so like how this one's quadded up here, and we can do that with all of them.
Yeah. I think my brain might be the limiting factor.
The only ones that aren't on the system are the ROV pilots.
Yeah.
There's just direct.
Over there.
Yeah.
That's for the latency.
Yeah.
Because when these crabs come after you, you got to be fast. Hey, I'm ready whenever y'all are, by the way.
All right. Start a line.
Number 9. Yeah, it's there, right?
Yeah.
You say something's not right?
Oh, no, it's fine. It's C-log doesn't update on the piece that you work on.
Shut it, restart it.
It's all right.
It's there.
Yeah, that's why we got this one to check. It's all work.
How many CTD runs are they going to do?
It's a yo-yo for like 12 hours or something.
Yeah, and they were taking about 30 minutes, so that was 24.
Yeah.
So we should probably see if they need, breaks for lunch or whatever. Huh?
They've been making their way through.
So
Yeah.
our guys can relieve them,
Yeah. They've been rotating through, I think.
They're rotating through. Are they coming on deck at the end of every one of these?
No, just to the surface.
Is the surface?
Yeah, just to the surface.
Yeah, I think so. That'll be a quick one. Are you feeling?
You just don't know where you're at.
So we're back down to 21, and now we're moving to the.
Oh, we're getting closer to the big coral.
And so how do you do it?
It's gonna happen.
Oh yeah. I don't know if he's going to get it this time, but he's going to
Yeah.
I don't think it's this time. It may not even be next time, honestly.
When it seemed like it was pretty far, sometimes it would come back under. Yeah, or gone in between the two.
This is going to be a cool one.
It's good because that's like that. Keeping there. And there's also
Probably when you were doing the multibeam.
This is actually
That was mine.
good job.
I watched biology and I saw about 3 fish. I can't stop watching, right? It's something like this.
Yeah, I usually try and find a feature on the bottom and then see it on the next one.
It's definitely one person who's doing it.
Oral pricing.
Fish knowledge is not great.
Seems to be on the top.
And I missed the last one because I was talking to Dan about the plan for the next one.
So you know what's in the
So see what the story looks like. So it's a good place for science meeting? One of you want to stay, one of you want to go, or you definitely know what happened, and you know what the plan is for tomorrow.
That's true,
so
yeah.
you're probably good.
If it's sat here for ages too, I can do some of this. Yeah, that's fine.
Yeah, next one will be good.
You think so?
At least partly.
Yep.
Jake, were you able to tell me what time you started the laser scanner? Was that in 05?
Yes.
2005, so that's 1.2 hours ago.
Yeah.
Okay. Alright, thanks.
Okay.
Alright.
When you came in earlier, just watching when we were multi-gaming, right, there's a whole lot going on, and I was struggling to stay awake. So we're sitting around here, we go back towards our original Atlantis site and go the inside of Caldera. When we get that, we start from the outside. Because one idea is the current control, right, on where these things are occurring. Just not the outside.
Okay.
End of line?
End of line. Fine. Yeah, so the other idea is that it's the oxygen control, so more of a depth thing. So we want to start deeper than we found it on the outside, come up to where we found it, and then go along the top of the ridge, you know, on top of the rim, yeah, and crisscross from one side to the other. So you both go shallower, but also go from inside to out repeatedly.
Yeah.
And we can stop doing that if that appears to not be interesting, but that's like one hypothesis, right? Is that it's the difference between the inside and the outside. I think we might need to write this here down. And then we also talked about full
work mode. Yeah.
I think
That might be one of the ones Doug was telling me we've been having to tape.
That's gonna
The joints are wearing out, but we have some more. We just ordered some more. Yeah, I guess some of them you can't really even tighten them anymore.
Yeah, so then I think it is talking about
wobbly, you know?
But the fossils are just deepest in the sea. That's when the Atlantis died, yeah. And we can all see the ages of the dead stuff on the inside and the dead stuff on the outside, right? And it's saying if one more dead stuff above it as well. Is that the same age as the stuff below it, or have you got like basically if you got like a vertical migration of the zone they can live in, yeah, it would be yeah, exactly. There's a lot of hints. But should be fine. And there's some steep slopes and try to get some of those which could be hopefully of interest to the wider group as well. Yeah. That should be good. So
If you're just joining us, you are watching live footage from the remotely operated vehicle SuBastian.
Okay.
Being piloted from onboard research vessel Falkor 2, owned and operated by Schmidt Ocean Institute. And we are currently doing some mapping runs here at about 485 meters below the surface of the ocean off the Galapagos as our second dive in the vertical reefs of the Galapagos expedition. So every once in a while you'll see a little strobe on the screen. If you are just tuning in, there are a lot of flashing lights this particular dive. But sometimes you'll also catch sight of a blue laser. In fact, I can toss this up. You can see the little laser cutting across the screen there. So these are part of the mapping, part of the suite of mapping instruments that we installed on SuBastian for this dive. They are meant to capture very high resolution, a very high resolution capture of the seafloor here. All these corals that we're going over, the various rock terrain, the cool little crab hanging out the sponge. All of this will hopefully be captured in a pretty high resolution scan of the area. So, unfortunately, we can't really stop during this mapping part of the dive, so we won't be stopping to smell any flowers, but we are still seeing lots of cool stuff. And Tyler over in co-pilot has been kind of zooming in here and there where he can. Zach in pilot seat is using mostly the situation cam to fly, so Tyler's been able to kind of point the science camera around a bit. Ah, yes, if you heard there was a good octo, if you go all the way back to the first couple minutes of this dive today, we had a great appearance, a great cephalopod right at the very beginning. We've got about another hour or so before I'll be restarting the streams, and then again, this is like a 24-hour dive, of which we're only about 7 hours into, 7.5 hours maybe, but it is going to be a lot of this mapping, so more of a chill stream, just kind of relaxing, hanging out.
Dude, do you all mind putting that waterfall back up again? From the lady? Thank you. Let's help him stay honest here.
Yeah, Zach's been watching the waterfall that you see on your screen there to kind of judge his positioning of the sub. You can see that strobe, of course, taking many, many photos of the seafloor in high detail. And if you just push down just a smidge there, Tyler, so they can see that laser real quick, then we can look back up. So there's that laser. So it's a straight line, and as it goes over the varied terrain of the bottom, right, that kind of distorts that line. And so if you just imagine that over and over and over and over, all those lines, all those distorted lines being laid on top of each other, that's sort of the waterfall that we get. So over time, capturing all those little distortions, we will build a high-resolution image of the area. I mean, in terms of resolution, we're looking at millimeters. Scientists here are hopeful we'll be able to perhaps even see like polyps on corals and that sort of thing. So it'll be neat to see what the data can be turned into. But it's going to be a lot of post-processing.
Yes, the processing of this data is pretty complicated.
Yeah, I've got to imagine. Yeah, I mean, we're at like 17,000 images right now, and who knows what sort of cloud is being made by the laser.
Yeah, do you know much about the laser processing?
I haven't got much experience with laser processing, but I have quite a lot of experience with acoustic processing, and in some way it's the same thing.
Mm-hmm.
In acoustics, you make a line of
Okay.
echoes. End of line?
End of line.
Bridge, CTV, 100 meters from the surface. Roll it out.
Yeah, it's quite similar to that.
So the maps before the delivery point with the laser in the wrong space is similar to putting a big beam onto the beam at the sounder in its wrong position.
Okay. Yeah.
The way to extract that information from the raw data is a bit different because here we just thousands and thousands photographs of that line,
Yeah.
and you have to extract the information from that while it makes it see the train method the points of the more direction. So yeah, I have not done this before. It's all a learning curve.
Yeah, that's very interesting.
Ladies, yeah?
Yes, the latest.
So they have changed that. So.
Yeah, we're doing that. Is the meeting finished? Is the meeting finished? Yeah. I just had it. But yeah, at some point you can use the actual.
See, it's getting a little hazy off to our port. Not too bad yet. Stream is still holding pretty strong. So, like I said, about an hour we'll restart the streams on both Facebook and YouTube, but we're looking okay.
It's not just showing this, it's that. Because doing those doesn't take it for jobs. Because when it means racing, so it would like to race more. Then way up and then driving the RV backwards. Yeah, but you only get good news. Yeah. But she's only doing one flight after another.
Oh, there's our friend, huh?
Yeah.
It's a big one. It's cool. It's just chilling there.
He's quite tall.
Yeah. What do we think? This time? Are we getting it this time?
Well, we got him last time.
Oh yeah?
A lot of them.
I missed that we went through.
This time he can be kind of in the middle almost.
Oh, that's good. Yeah, the dives of this expedition are going to kind of alternate between collection and mapping. So this one happens to be 24-hour mapping, just trying to get this little chunk of the area. So our first dive to the area, we did get some samples, and we also kind of scouted and found some areas we were interested in, which now we are trying to map with the mapping equipment.
Marker here, it's nice fancy. Look at it for.
No, but we totally could.
Yeah, because he asked if we see big fans like this.
Although just remember, it's going to be pretty hard to get a good view with the laser ray frame.
Well, we don't have to do it like today for this area. Put a marker here for BBC.
I'll finish this line and then I'll pass it over to y'all when it's almost done. It's not.
Got a little handover about to happen here.
How are you finding the 10? Are you 5 meters off now, or?
I'm
Oh, so we have someone asking if we've mapped the area before.
I don't know that I've been watching the speed real close.
Kind of.
So just letting
Let me pull that
everything get
up.
a nice soak in the laser as it goes.
All right, so you can kind of see the map here. This is the area that we've been working on today. And so we have a multi-beam unit on, and that multi-beam will give us centimeters resolution. We also have the laser, so the laser unit can give us millimeters resolution. Prior to today, or prior to us coming out here, we had a, oops, lost my mouse. We had a 15-meter resolution of the area. So you can kind of see there's this, I'm just tracing it with my mouse here. But there's an area of kind of different resolution. So you can see it right here, it kind of comes down like a little hockey stick and then off to the right. So this is us. We just scanned this in 5 meter. And then when we first showed up, it was in 15 meter. So we're slowly getting more or greater resolution, right? A finer resolution. So 15 when we got here, 5 after we hit it. So let me zoom in. You can see this line right here, and then there's another hockey stick curve over here. If you can see where my mouse is on that map. So on the outside, that was the 15. I want to say Kat said, and then on the inside is the 5, and then where we are now, we're going to be getting centimeters to millimeters of resolution scan. So slowly dialing down closer and closer. You can see this little spaghetti of a snail trail going on here, where we've just been going up and over, So we just had Chris hop into pilot seat and Adam in co-pilot, and then I'm still here in the multimedia technician seat. Oh, okay. Folks are saying they don't see the map. All right, let me toss that map back up. I thought I had the map for y'all. Here we go. Here's the map. I think it was in my preview window, but never actually moved over to the program window. So here we go. Now you should see the map. I'm going to put a little picture-in-picture for us there. So to give you an idea, you can see where we've been going today, just back and forth, and especially over in this little area here. There we go. We got you all the map now. It's been a long dive, but it's not even half over yet. I don't think so. We're gonna get there. All right. So then, as I zoom out, right, this is the. Sometimes you'll hear us talk about the crescent seamount. This is the crescent seamount. And so there's an area. Let me turn here. You might be able to make out that there's a little swath right here. Looks like another little crescent being spooned by the larger crescent of the seamount. So this area underneath it, 15 meters resolution. This area now that we scanned, that we're in currently, 5 meters resolution. And then where we're scanning, this tiny little chunk right here, where we went back, forth, that's going to get centimeters resolution from the multibeam, I think is the plan. And then this little area here where we're just all over the place and we got that crazy snail trail spaghetti going on, that's going to be millimeter resolution.
That's about right. That's it. That's the right distance. Perfect.
So there we go. Glad I got you the map. Thanks for letting me know. Apologies for the confusion. You're not crazy. I'm crazy.
Yeah, we try to see if there is a picture. It's not always easy. But that's the big coral we had in the middle before, so now we are going. Yes, we are setting this over. But remember that this is swapped, and this is swapped.
I can be joking for now, I can't.
Yeah, the lines are all set to
This is spot, right?
Sorry?
I got confused by that.
Yeah. It's because of the way they had to mount the multibeam system. Perfect.
Yeah, we've had lots of these little cat sharks, and then we've also had the bunch of little tiny chimeras around, which is fun to see.
Yeah, this is about and I think a bit worse than that, you have to fly species cluster or say fire fires, special circuits, yeah, tiny cluster between species.
Alright, that's the end of this line. Thank you. I've come all the way past this.
Yeah, if you go all the way past that, then you really need to have the top.
ROV and bridge coming off bottom. The bridge.
Roger that.
Okay.
Happy?
Yes, very happy. Thank you.
ROV, that's an updated link. Thank you.
Stick around for 10 more minutes. And then, if you want to show me what you're doing, then you can go, because you're not on YouTube. Emmy.
So whenever.
Yeah, or Abby, or.
So, you'll be about 70
whenever you start a line.
So it's
Much easier. Start a line and end of line. And just a line and line. And then, yeah, whenever we started, just to keep track of the number as much as anything, and then we have these notes going. Just copy this line.
No, very
Yeah, I know. So when we start the next one, it'll be start of line 13. Copy this line.
And then besides the laser, I've mentioned it a couple times, we also have the multibeam on board, the sub. So you can see a little feed off of that there. But currently we're just hitting this area with the laser. So.
And that's it?
Yeah, and then the end of line, same thing, mapping transect. Yes.
Good.
Yeah. Yeah, I can stick around for that bit. Yeah.
You're off shift.
You sure? You don't want to take a break for 10 minutes? Or?
No, it's fine. I'm looking for all.
Oh, I'm sorry. I was like, swinging by something.
I will rest while we do the DVL. I think. I guess we will not be during the DVL. Yeah, but we can find it.
Nice. Enjoy.
Thank you.
No.
James estimated about 5 minutes. Sorry? It's only 5 minutes to do that. No.
Alright, we're just it's hard to get a good picture of the side cam just because the light.
Yeah.
And of course we're playing. Ready when you guys
No, just what it is.
Yes, we are ready.
Yeah?
Start of line?
I'll leave it off to the side.
Let me bring the
Yeah, no,
that
that's fine.
altitude down just a little bit.
We appreciate it. And I kick over to Sit every now and then. Like Sit had a really cool flyover last run, so.
And some of these aren't bad. Like that's not a bad day there.
No, yeah, no, I kick around to him. When we're running a line, though, I put up. Yeah, I do this, so it's got like the waterfall.
Right.
Biggest creature on these dives. I mean, probably the octopus at the start of the dive is quite large. We haven't encountered anything too crazy. I mean, we've got big corals, right? If you want to count like the colonial critters. That's fun. Like that laser.
Yeah. We're maybe a bit close. Yeah.
A little bit.
Sorry? Oh, yeah, you have to. That's this way. Yeah. And then you have to make sure that that they can see the flow. Yeah. That was
Yeah, for this cruise, we've only done the 2 dives thus far. So, biggest critter's probably that octopus. But, yeah, for the dives I've been on, you know, we were getting the sharks and the rays up at the surface back during the Monica Bright dives. The Underworld of Hydrothermal Vents expedition. That was cool. We had a very large deep staria on one of those ascents as well, that like I feel like a person hugging their knees could have fit inside this deep staria. It was pretty crazy. There's one of those little chimeras. Just off the bottom of the screen now. Can't stop. But this is a fun shot of seeing the laser and sort of the alteration in what it looks like. Oh, Adam's finding laser sounds for our laser now. Yeah, so if you're just joining us, we were just talking about the lasers a little while ago. So if you watched our first dive of this expedition, right, the expedition we're on right now is vertical reefs of the Galapagos. So you have these cliffs along seamounts which have cold water corals growing on them. And those are difficult to really map well using your standard mapping because most of that is done from the top down. And so when you're trying to shoot a cliff from the top down, everything gets super compressed, you know, as far as the area it covers, because it's mostly a vertical difference. And so what we're doing now is we're actually trying to map these cliffs using a variety of tools. So on SuBastian, on this remotely operated vehicle that you're watching footage from right now, we have a multibeam echo sounder on board, and we also have this laser scanner. So the laser scanner is firing at 50 hertz, and basically you can see like it's a straight line, but when it's passing over little variances in the terrain, that line is not straight anymore, right? And so by stacking up that line over and over and over, if you think about like each time it goes over something and it gets deformed, we can stack that up and we get this little feed here, and this will be able to be processed into a basically a scan, a 3D scan of the area with potentially millimeter resolution. So we're really just trying to map, but it does unfortunately lead to a lot of weird lights and flashes, and it's just a lot of driving back and forth. But we're still seeing some cool stuff. We just can't stop, you know, so it's these fleeting moments. So you have the laser, but you also have the strobe, and when the strobe is firing, there's a camera that's taking a photo of that strobe. And if you think about like when you're riding in a car as a kid and you look out the window, things closer to you appear to move faster than things further away from you, right? So that's called parallax, if you're familiar with it. And this strobe that's taking pictures now, if we can get an item, or if we can get several items in 3 of those photographs, 3 frames, we can actually apply a computer algorithm to it called structure from motion. And it takes into account the fact that something closer to the camera will seem to move faster than something further from the camera. And it can actually construct something of a 3D idea, maybe a 3D model, but it's going to be a less detailed model than you might be thinking of. But we can actually use that as well. And so, yeah, we've got a couple tools on board to give us really nice high-resolution 3D models of this area. Yeah, part of the, you know, someone asks, is the data going to be actually published publicly? Yep, that is one of the things we do. All the scientists, all the science teams that come on board, every expedition has a different science team with a different goal, something different that they're looking at, and all of that data eventually is published publicly. We have it over at our website. We actually have a little publications tab there at schmidtocean.org. You can also find information there about the expedition itself, both the current expedition as well as past expeditions, and two future expeditions. We have 2 more expeditions this year coming up. And then once we publish details for what our plan is next year, we'll have that as well. Yeah, it's definitely a different dive, right? Like there's a lot of jokes about like biology dives versus geology dives, right? And like the geologists want their rock and the biologists want their biology. But yeah, we got a mapping dive now, so I don't know. It's gonna throw off the balance of power, perhaps.
Mapping dives forever!
Mapping dives.
We need to follow. Okay, so here, when we start again, as we start offline, I put 14 and submit. Yeah. And then after I do that, I write here line 14 and copy paste think it's like a bit changes. Yeah.
Yeah, so folks who might be new jumping in, welcome, welcome. We do stream all of our dives, so if you're catching us on Facebook, obviously you can follow our page there, or if you're over on YouTube, you can subscribe and get alerted whenever we are live. We also put out like weekly update videos on the expeditions. Usually each expedition gets like 3 videos plus a highlight reel plus an interview or 2 with a scientist on board, kind of about their career. Plus, you know, we get artists that we bring out on the ship to kind of be inspired by the science that's being done. So yeah, all sorts of cool stuff. And then down in the description for this video, you can also find links to not only our website, right, schmidtocean.org, but our Twitter, where we post about the cruises, as well as Instagram. And then our YouTube and Facebook are in there, depending on where you are right now. Also on Twitter, good to say we do have a nice little community that follows along with our dives, and they'll frequently you know, post screen grabs or little clips or just snippets here and there, and each cruise has a hashtag associated with it. So this is the vertical reefs of the Galapagos cruise. The hashtag is Cliff Reefs. So if you check that out over on Twitter, I suspect there are already some screen grabs going.
And here, if I go to biology, how do I go back? Biology, and then here is not.
Actually, the one thing I'm thinking is that we're now recording on NS login, right?
Okay, I should log out so that it's I haven't created a user in my moment.
Actually, in there.
Adam, does the waypoint numbering matter? Do you want to start back to 1? Or can I start back to 30?
So we've been going for about 8 hours, bottom time of 7 hours so far, stream time as well, 7 hours. This dive is supposed to be about 24 hours total, so we are not yet even halfway.
Sure. There shouldn't be as many waypoints as this time.
Folks asking about other social media. Not yet. You know, we always discuss things here and there. It just takes more folks to manage it. While we're diving, right, myself, or if you tuned in, like the last 2 cruises, Sophia, we're the multimedia technicians. So we're the people who are running like the YouTube and Facebook streams, but we don't do the YouTube videos outside of that really, or the like the Facebook posts. Those are other folks. So we also have multimedia coordinators on board, and their job is actually editing together the clips. Soph and I will pull clips through the dive, but then the multimedia coordinator is actually editing those. So that's all the weekly update videos, and the like the science at sea, scientists at sea videos, science stories, artists at sea, excuse me, the highlight reels. And then Twitter, all right, there's someone else that runs that, as well as like Instagram. Soph and I don't touch those. So yeah, lots of people juggling lots of stuff behind the scenes, but we're always discussing sort of how to spread out more, and right, bring the deep sea to more people. That's, I think, the most exciting thing for a lot of us, is just the ability to bring the deep sea science as it's happening into, you know, classrooms and auditoriums and living rooms around the world. So always stay tuned.
Okay, so you say till 6, then I'll
Is there any chance I could get a mouse like that? I'm a little bit on off the speed, but if not, it's okay. I just know that I get recorded Australian when I'm doing this one.
How much maintenance needs to be done after a 24-hour dive? It depends. For this one, I think one of the big things is going to be, I believe the next dive will, I don't know if it's been decided, but like hypothetically, right, we have a collection dive and then we have a mapping dive and then we'll have a collection dive and then a mapping dive. Probably won't work out that way all the time, but let's say next dive was going to be a collection dive. One of the things that we would have to do is swap out the mapping equipment, because right now that is on our porch. So if you haven't watched the stream before, let me put up the porch here. It's in shadow because we have low lights on while we're doing this mapping, but there you can see the porch. So you can actually see the camera. You know what? Let me get the circle if I can. Oop, not that one. All right, so there's our circle. Unfortunately, moving it around, we need to organize this a little bit differently. So let me turn it off here. I'm going to walk you around the porch here.
Yeah, I mean, it's not correct. It's not very much.
So actually, it's really only one thing I want to show you. So right down here, that's our camera. So that's the other camera that we've been seeing. And it's kind of angled right now because we have that little laser assembly in the way. And so when we swap out, we're going to have to take this whole system up here, which is mounted down to the deck, down to the porch, as well as there's a strobe over on this side. There's a strobe over on that side. We're going to have to remove all of that. And then all this wiring that's down here, that has to get all pulled out. So before we do a collection dive, this whole area here will be, everything we just went over will be taken off, and then we'll fill this area of the porch with like bio boxes, which are boxes for putting samples in, coral quivers, which are like a different little container. Sometimes we'll put milk crates with tools on there. Depending on the needs of the dive, we can put other tools. So like that's a lot of what goes on between the dives we have for this expedition are going to be basically making sure that the ROV is set up for the next dive. But you know, there is other maintenance that needs to be done. You know, the ROV has a lot of electronics on it. Obviously, it's got the cameras. So a lot of cleaning, a lot of swapping parts. What's like the number one maintenance thing on the ROV, Adam?
Narrow it down, yeah, we do a lot of, with the hydraulics, there's a lot of maintenance on the hydraulics.
A lot of maintenance on the hydraulics, and then everything, right, like we deal with pressure, so there's a lot of oil in the system that needs to be, you need to make sure that's all working right, because that's a big part of the system. So, yeah, hydraulics for sure. But, I mean, on the other hand, right, the question was after a 24-hour dive, like, how much maintenance, right? Really, 24 hours is nothing when you're looking at, like, the industry ROVs. Like, I think we asked J-Rod one time, and he was saying he was out for, like, several weeks on end, and the ROV was basically in the water the whole time. So sometimes it can be quite a long time that's in the water without really getting fixed. It doesn't need fixing. But other times we just have to do work on it. Whenever scientists come on board, right? If you're not familiar with what we do, Schmidt Ocean Institute, the scientists on board aren't Schmidt Ocean scientists. Like I mean, we consider them part of the family, but they come on. We allow them to use the ship and the ROV. That's all free for them, and that means that like every expedition we have new scientists on, and they always bring like new equipment. There's always this challenge of figuring out how to integrate stuff onto the ROV. So when we heard that there was going to be this like laser scanner, right? The ROV pilots start looking at like models of the ROV and measurements that the scientists provide of their equipment, and they try to figure out like how are we going to fit this on there, because the laser isn't ours, right? The scientists brought that with them. And so a lot of times we got to figure out how to integrate their equipment onto the system. So a lot of stuff. All right, so that's the end of that line. We'll go back to this camera for now. We're up to 20,000 images captured so far. So there's going to be some processing work to be done. There's that big fan. That's great. I love those squats with the super, super long pincers out there. See, take a look outside again. Yeah, there's some clouds there on the horizon for sure.
No, tienes que crear tu único, porque así sabemos quién hizo la tapa. Sí.
Actually, I might do that. How far down did you drop over that cliff?
I don't know. This cliff to the other side.
Yeah, like right here. Like even back.
2 meters.
Oh, it's not that tall.
Ahí dice, pon as logger, y en el logger debería decir register new. So am I speaking too loud? It would be authentic if there's a Spanish in the background. Why not? No, yeah, to start off. I noticed that when I did the start off line earlier, I did the 0.1 and I go back. Okay, but now I know always 0 is not right. No, I know.
So let's see, what step are we on of our dive plan here?
Ready for the next one?
Yep.
Alright.
Start line.
Start line.
All right. Yeah, I suspect at some point we'll be taking a look at that large coral because we want to try and image a large isolated coral with the laser, just scanning it from all over. So.
Can I see what I found?
Yeah, this is one of our shallower dives that I've been on this year. Or, yeah, I suppose it's tied with the last one. This expedition as a whole will be pretty shallow as things go. Most dives won't be deeper than 1,000 meters, but the past couple cruises we've been doing over 2 kilometers. So. And ROV SuBastian is rated down to 4.5 kilometers. The umbilical, the tether that connects it back to the ship, is 6 kilometers, but the ROV only goes down to 4.5.
Sorry?
You can put the taxonomic you can choose the taxonomic identification that is comfortable with you. So if you know that it's a coral and not a sponge, that's good. If you know what the next level of type of coral is, then put that. If you don't, someone else can go back and review it.
Yeah. It's just like thinking, how can I figure out what the understanding moment that somebody needs to help grow as well.
Yeah, one of the things that actually assists with the winding back up of the umbilical, right? Like, because if we spin around a whole bunch and then come back up just like that, not great. So it's actually one of the things that the pilots can keep track of is how many rotations the ROV has made. So if you turn 6 times to the right, and before you recover, you turn 6 times to the left. But it's just one of the things that they keep track of. I'll show you one of the interfaces.
Yeah, Jimbo was just saying like there's a light hanging down from the seat or something. Yeah.
Can we grab my cable, please?
Okay, so now we're going to add an issue where this lifting is further between east and forward. You know what I'm saying?
Like you were about to
ATV 1 meter below the surface.
All right, so this is just one of the pilot's interfaces. Let me, now that I've interrupted everything with that, I'm gonna put up a little pip up in the corner there. So up in the upper left corner, quickly before I cover it, you can see that there is like a little representation of the ROV, and you can see which direction, like our heading, where we're facing, but there's also a little representation of Falcor 2 on top of the ROV there. This is in the upper left corner, and so we can see what the heading is there. We have our current heading, so yeah, and then the numbers telling the pilots sort of the positioning of the ROV. So I'll put a little pip up there so we don't lose anything. Immediately under that we have our depth and our altitude. So we're looking at how deep are we on the left, and then on the right is how far off the bottom are we. We actually only get the altitude once we're within a certain distance of the bottom. We have data from the winch underneath that. So basically the thing here is like how much is paid out, what the tension is. These are all things that the pilots are keeping tabs on. You'll also see delta. So delta, you'll hear the pilots refer to sometimes, like if we have the mics on during mid-water, you'll hear them talk about it. So delta is a relationship between the actual depth of the ROV and how much umbilical is actually paid out, right? So like we're at 480 meters, but we've paid out 556 meters of umbilical. So we have a delta difference of 76.2 meters. And so, you know, we can't just have the exact amount paid out of the depth we're at because there's currents along the way. So, you know, there's things pulling at that umbilical. And also we have like a little loop in the umbilical that takes strain out. So if the ROV is kind of going up over things, catenary. Adam's writing out words for me. So yeah, the catenary, and it'll take strain basically. That if the ROV is going up over, or excuse me, if the ship is going over swells or something like that, the ROV can remain unaffected by that because we have this slack. That being said, right, if we had a delta, like it's like, why not just play out all of it? Well, because then we'd be dragging an umbilical around, or you know, it's dangerous because it could get snagged behind us, especially like if you think about the terrain where we are right now. We don't want to have a big umbilical just like hanging behind us. And so keeping track of the delta, making sure it's not too much, but also that it's enough. Yeah, there's a lot the pilots are keeping track of. Then we have the ROV information underneath. So speed over ground, course over ground, and heading. Over on the right side for this particular screen, and so there's a bunch of different tabs, like they can bring up all sorts of stuff, but right now over on the right side you've got all the thruster information on the bottom right there. So we have the 5 thrusters. We have the thruster in the middle, it says like 29, is our thruster that points up down, and so no, that's not correct. It's side to side. I was like, that's not correct at all. It's side to side, excuse me. And then up down are the top 2 there, and then forward back, or you'll see one is like negative and one is positive sometimes, that we can also turn that way, sort of like tank controls. But yeah, the one in the middle is not through hull. The one in the middle is side to side. So which is kind of still through hull, I guess. Yeah, yeah. It's not up through the middle. Do they have special names? Are there special names for the different thrusters?
We call the vertical thruster the verts.
The verts, okay, yeah, for the ups down.
And then the lat.
The verts and the lats.
Yeah.
Cool.
We only have the one big lat.
Yeah, just one in the middle.
Just the one lat. Sweet. And so yeah, this is, like I said, just one of the interfaces that the pilots deal with. We've also got like interfaces for the cameras. We've got interfaces for the lights. We have interfaces for all the electronics on board. You know, there's like little sonar interfaces that they have. So lots and lots and lots that the pilots are keeping track of.
have got much with us to start with collaboration and getting the permits. So my team and I were helping do this so that we have also.
Yeah, usually the only part of that screen we pull up is just the map, because otherwise there's way too much going on there. And we usually have it as a picture-in-picture, so just even reading it would be a lot. What else do we have? We don't have Blue View running.
We have the sonar turned off right now.
Yeah, because they're doing all their sonar stuff, so we don't want to have ours on. So.
Ready for the next line?
All right, just in time to start another line with the laser.
Start? Yep, go for it. Yep.
And then also, like, I mean, the pilots have been using the equipment that's on board the ROV for the scientists right now. They've been using that a bit for monitoring as well. So, like, you heard Zach talking about the waterfall, and we've got it pulled up over in the corner. Chris can see it as well. So this waterfall that you see on your screen, that can be useful to them because the color kind of, they're trying to get just the right shade, so they need to be able to see that. The multi-beam was being used earlier. Adam had me pull that up over there so that they could see that.
So I think that's one of the two reasons why I'm here, just as part of the next team, but also because I can
And then in the pilot seat, there's actually another little console right in front of the pilot that has more controls and interface, some of it being exactly the same up there, but just another screen for them to look at and keep track of. Yeah, images. Let's see how many images we're at. 21,200 images currently. Data-wise, I don't know. I mean, like, we ran it for like 2 hours just testing it, and it was something ridiculous already, like 130 gigs. Like these little red rockfish on the cliff here. They've been stayed pretty put, so they might get scanned nicely.
ROV science control, that's the CTG, that's 100 meters off the bottom.
All right, CTD, 100 meters off bottom. Nice anemone.
You're welcome.
I felt like what deep sea needs to be part of was against like after this extension, you depend on other exceptions to come as Europeans, and then we are like the US need us for the climate and so as someone who wanted, I realized like
Copy that. We're just about at the bottom now.
Sorry, did you say 10 degrees to port?
Correct.
Copy that. I can slide him back to two more lines and launch point. It's basically, it's pulling you a little bit forward right now. If you're happy with that,
Right now he can definitely.
I'm just gonna run master move. That's cool.
Alright. And the line?
And the line.
And the line.
And there is another line. It's line number 16.
Hey, Jason, out here. I'm just gonna slide you back about 20, 30, 40 meters here. Work for you? Somewhere about there.
Yeah, that works. Yeah, we're on the way up right now. We're coming up to 50 meters off the bottom. So yeah,
Thanks.
I think right now, I'm not sure what rate, how much detail they're looking
Good.
at. She already was saying that a little bit to
Yeah, there is a lot. Mains dropped 2% from this morning.
Yeah, the mains dropped.
the science control, that's the CTD 100 meters off the bottom now.
Copy.
I have already published my one chapter, which was the easy one, which is the discovery.
All right. We're coming up on the top of the hour here. We're also kind of where I'd like to restart the streams. So I'm just going to take that opportunity before we start this next line. Although I can't promise we'll be back before we start that next line. But I am going to restart the streams. So if you're watching us on Facebook or YouTube, just sit tight. Stream's going to end. New streams will take their place. So we'll be back in just a little bit.